We are live.
Okay. Hello and welcome to Qubes OS Summit 2022, day one. I'm Piotr Król, I'm CEO and founder of 3MDep, and I have pleasure to welcome you at this conference. Here is Marek Marczykowski. Want to say something?
No, go on.
Okay.
I will just stand here.
Where's the slides?
Okay.
Okay, so the first thing to do is to clone the cube.
Okay, you can start.
Okay. So first of all, thank you for coming and thank you for spending your time with us. I know that this is already some investment. You came here, and I want to talk a little bit about what we can build together and maybe try to justify why I care about this conference. So first of all, we lack human-to-human interaction for last, I don't know, 2.5 years or something. And I believe that direct human-to-human interaction may help us build trust to each other. And if we want to be reasonable, secure solutions, trustworthy solutions, we have to trust each other. So I believe this is first good step for that. Other thing is, of course, we have these problems in mass surveillance and all the big platforms that stealing our data all the time and try to spy us every day, advertise and decide about what we're thinking, who we love and who we vote to. So we also probably want to defend our identity. And because we all came here, we probably have some shared vision. Maybe the tactics and the strategy of individual people is different, but eventually we spend our time here. We want to commit to Qubes OS growth and probably whole reasonably secure and trustworthy solution growth in the ecosystem. Also, I believe that there is this problem of lack of or not enough synergy between the firmware and operating system world. That's why I think that meeting the firmware people with operating system people and talk about low-level stuff and how those two worlds interact is very important to build good solution. Finally, we have problem with the sustainability of open source. At least I don't see here big brands in terms of there is no Google here, there is no Facebook here. Where are they? They are kind of not visible here, but. We have some partners already here. I will welcome them later during this presentation. But we need sustainable business models for both for firmware, for operating system, because otherwise we will not be able to continue our work. Okay, so I wanted to say a little bit about the history, but Michał Żygowski already wrote a guest post on Qubes OS news site. So I really recommend reading that because it explains everything about how the event was created and how it started. But maybe just to say it short, it started as a mini summit joke, we will say like this. We called it mini summit, but it was just a couple people from 3MDep and Marek in 2019. This was very surprising because we bought a training for Linux kernel development, and who appeared? Marek as a trainer. So yeah, we couldn't. We have to use that situation, and we just asked Marek if he would be okay to have some small event. And yeah, and that's how it started. And now we continued. And there were 2020, 2021 where we did virtual events. This was quite successful, and. Finally we are here and we are, live face-to-face meeting. Also, what I believe happened over these years of Qubes OS summits or mini summits was that Qubes really build awareness in the ecosystem in terms that we need open source firmware, we need good hardware compatibility, we have to leverage most modern hardware security features, and I believe the Qubes OS is very good at that, saying, okay, you will have certified hardware, but only if you fulfill these requirements. And one of these requirements are open source firmware and some reasonable settings, configuration of low-level stuff. One more thing is about community, which is also, I believe, some achievement of Qubes. Qubes got great community, and I would say it's the awareness in the community is huge, because you realize what is ME, that ME is toxic, where you realize what's SMI, that this also can cause some problems. You know that isolation is important, and so on. That's another thing which I think why Qubes community is great. And finally, I think Qubes community rules because they are brave. So, for example, we did release of our product, Dasharo, open source firmware distribution, on MSI platform on Intel Alder Lake, and first person who tested that outside 3MDEP was Qubes OS user. So that's great. Yeah. So you are fearless, you are brave, and that's why I think this conference is very important to meet each other and talk about that. So those are logos of previous events. Maybe talk a little bit about accomplishments. So what we were able to accomplish working together over the last 3 years. I believe it's worth to divide kind of time space into 2 sections. First, 2019 to 22, and I hope right now we like starting new chapter which will last for next 3 years, let's say until 2025. And what we achieved so far, and then I would like to talk about the challenges and maybe something with opportunities maybe that we missed. So first of all, we were able to integrate FWPD LVFS support, so firmware update support in Qubes OS. Of course, there were some caveats, small things that still have to be improved, but we're working on that. But initial support was contributed. Then, from what I saw 3 years ago, 2019, there was 0 laptops certified. Right now, we have 3, and I believe thanks to open source firmware evolution, we have new platforms that may be certified soon, like this MSI, the Optiplex, probably some Protectly platforms, probably some Nova custom laptops, and that's what we hope for. Then Zen contributions, there are some small Zen contributions regarding AMD dynamic root of trust for measurement. Maybe this is some more advanced security topic. We will discuss that tomorrow widely when we will talk about the next thing, which is Trenchwood project. Trenchwood project is open source implementation of DRTM and kind of T-boot port to more compatible environment, I would say, or more compatible code. So we want to have anti-evil mail support on TPM 1.2, TPM 2.0. We don't want to be limited to Intel TXT. We want also have that on AMD. And that's what Trenchwood project trying to do. And we already have agreement that this will be done. And we already started that. So I believe this is part of the accomplishments that we were able to provide. Okay, more to that. Initial AMD support for anti-evil mail. There are some draft patches not yet merged upstream. Second point I already told you, and we already tested and being able to execute anti-evil mail on old Intel 3rd generation platforms. They have some other problems, but this works on Intel, yeah, on Intel. There is a project that we're doing which is called FobNail, founded by NLNet Foundation. This is, you can say, attestation server on a USB stick, yeah. So attestation in your pocket. So it would be great if, in long run, we will integrate that in a vertical way: firmware, open source firmware, Qubes OS, and attestation. More to that, I already told you about MSI. There is also Asus KGP D16's very famous platform. It supported LibreBoot at some point, but code was dropped from coreboot, and we were able to get funds to re-upstream that. And I already know that Vikings is able to install Qubes on that and even sell that with Qubes. So that's also good. Another platform that can be supported. Finally, maybe not very related, but some people really love open power. So coreboot and heads were ported to Raptor Engineering Talos 2, IBM Power 9 based platform. And I know that Zen is in progress because Timothy already started some work on that. So who knows, if Zen will be ported, then maybe Qubes will be next, yeah? What things I think we a little bit missed, and we definitely discussed that during the past summits. So confidential VMs, this is something we're talking about. So secure boot, measured boot for VMs, yeah. It's already going, yeah. It's already started. There is safe boot integration in progress. I saw some issues on the safe boot repository, but it's not there. I don't know if we have a lot of value in that, but we discussed that, and definitely it would be great if we can move in that direction. And confidential VMs are widely discussed in corporate environment, so I think sooner or later it would be great if Qubes got that. New golden age of computing. The guys from RISC-V, creators of RISC-V, gave great talk. Talking about new golden age of computing, that there will be domain-specific computing, like the number of microprocessors will grow on the motherboard to provide domain-specific computing, and because of that, there will be more firmware. Yeah, of course, we love that. But that means that this firmware also can be leveraged to some extent, and I don't know how close we're watching that, and I believe to some extent we're missing some opportunities here. There is also a commitment of ARM and RISC-V to UEFI BIOS, which is not good, like because there is no one in those groups fighting for open source approach or using alternative implementations like coreboot. Reproducible toolchains is other thing that I believe is not moving forward. We had also a lot of this discussion. Okay, that's fine. We can build reproducible binaries, reproducible results of our work. But what about the toolchain that builds that? Yeah? So that's other problem. So for example, at some point we want to verify some old binary, and we would like to rebuild that, but we cannot rebuild that because the toolchain is not reproducible. We cannot get that toolchain any longer. And of course, we have problems with getting compatible hardware and trustworthy hardware, and this is what we're working on. If we're talking about vision and challenges, I hope we can provide we can provide solutions that can improve trustworthiness of every computing device. That's the goal. My hope would be to have vertical integration, as I said, like of Dasharo plus Qubes OS plus probably other hardware assisted stuff, and make it certified hardware in Qubes. Extend hardware compatibility. Of course, we always get these questions like, what laptop I should use? You know, what's the recent laptop for Qubes OS? What's the device that I should use? Yeah, what I should buy? This is something that we should have straightforward answer for. Incident protection, detection, and recovery. Okay, we have this Qubes, it's very secure, and then what if something happened? Like, can we detect that if something happened? Can we recover from that situation? And I believe the RTM, for example, can help here. There are new standards coming, like Trusted Computing Group reference integrity measurements and firmware integrity measurements. Those things, it would be great if we can use that and attest what was used before, use it for booting our operating system. And there are more hardware-assisted security features like SMI transfer monitor or PPAM. We can look at the commercial operating systems. They already trying to use that and trying to provide value based on those features. Memory encryption. There was also discussion, for example, in framework laptop community about Intel BootGuard shim. This is not so easy thing, but so like shim in case of secure boot and grab, but for very low level firmware stuff. And use of safe boot, we already talked about that. And I hope for more innovation in operating system and virtualization area. Maybe this is not my domain, but I would say like unikernels is something that we should look at, and probably lightweight VMs. I don't know if we can make VMs more lightweight, but you know, small, like cheaper hardware cannot handle really virtualization well. So maybe we can do something to make it more lightweight. And I believe the first thread that I mentioned, that building this awareness, like people understand, okay, Qubes saying that we need, I don't know, MA disabled, MA neutralized. Qubes say that we need open source firmware. Qubes say this hardware works, that hardware works, and that configuration works. And this building awareness of how hardware should be created to be secure and what kind of features firmware should expose to make it more secure. Okay, so let's get back what we can expect from this summit. We have 3 days. Day first today, and at the end we have social event. Then we have a conference day, so we will have talks and design session today. Tomorrow also talks and design session, and Sunday we have hackathon. And I believe we didn't decide yet about the topics, but design sessions are for deciding about the topics of hackathon. I would vote for confidential VMs, by the way. Okay, agenda. Okay, it's right now we have welcome. Then Marek will talk a little bit about Qubes OS development status. After that, we got Michal from Freedom of Press Foundation, building secure application with Qubes OS. Next generation of Qubes OS builder by Frédéric, and then tailoring Qubes OS for enterprise by Jan. I believe this is recorded talk and will be played here. Then we have lunch break, 1 hour lunch break, and we're getting back to some great adventures in UX and UI by Marta. I'm really looking for that talk because last year those were great talks about UX. Then Arthur from R-Compute will talk about a GPU virtual machine. Then we have isolating graphical user interface with power of Wayland by Puk. I don't know if Puk is ready. Great. And then Demi will talk about PipeWire and Qubes Video Companion. Qubes Video Companion, I'll talk about that last year, I believe. It was great. Like it is really great addition to Qubes OS. And then we have design session, which will focus on graphical subsystem. And 7:30, 19:30, we start social event. Social event will be in Suhr block. It's very close. It's like, I don't know, 150 meters. I don't know.
It will happen.
Okay, this is 10 seconds delay. Anyway, I'm sorry. So Suhr block is very close. We can take a picture, or there is also Matrix channel, Qubes Summit on Matrix.org. You can join that channel, and if you will be lost, then definitely someone will help you find out. A little bit of the rules. Please respect Qubes OS code of conduct. It is linked on the event website. Please follow safety and healthy protocols. We record the session, or unless someone said that don't want recording, then we will not do that. There is food and drinks. Please, you can use it freely. Channel I already said. If you find any issues related to code of conduct or safety and healthy protocols, please let us know. And you have other issues, please ask someone in 3MDev t-shirt, or someone from Qubes OS team definitely will help. Okay, so I would like to give a round of applause, starting with the organizer, especially great Invisible Things Track team and 3MDev team for organizing that. And special thanks for Marek, because he was very patient with me doing the CFP. This was our first experience with Pretalks, and it was great. Yeah, we recommend definitely this platform. And we have to give a round of applause for our great sponsors: Freedom of the Press Foundation, NLNet Foundation, Protectly, with brand R-Compute. I see there. NitroKey. Anyone from NitroKey? Not yet, but NitroKey Nova Custom will be tomorrow. So thank you very much for sponsoring this event, and it would not be possible without you. So. And that's it from me. Any questions?
Just FYI, my talk's title later wound up getting changed. It wound up getting merged with. So now it's modernizing the Qubes OS audiovisual stack, because it's not just about recording now; it's also about output.
More. This is more than you have to squeeze in your timeline all this new stuff.
I know.
Okay, that's great. So we'll have even some bonus stuff. Okay. So I believe, Marek, it's your turn.
We've got 5 minute break.
5 minutes break. I don't know if we want to take that one.
We won't.
We won't.
Okay, so hi everyone, and thank you for coming. And I will talk a bit about current state of Qubes OS, especially upcoming 4.2 release, but also.
Oh, sorry.
Okay, and but also I will start a bit about Qubes OS history, and that's because like about a week ago it was 10 years since Qubes 1.0 release. So. Yeah, so it all started 12 years ago, about 12 years ago, where the first public release was on April 7th, 2010. It was just a set of packages you install on top of Fedora 11. Installing Qubes was quite an experience. We didn't got this nice installer, we didn't have this nice packaging updater, etc. So it was quite an experience, but it was some features we see today was already there, especially the GUI integration of all the Windows. But for example, all the sysnet, sysUSB was not there yet. At least not in the default set. It took us next 2 years to finalize Qubes 1.0. And with 1.0 we had a standalone installer. You can just download ISO image and install your operating system. We have those templates included. At that point it was just Fedora template. Debian came sometime later. And also fun history after the Qubes 1.0 release. It got quite some attention, and our download server where we were serving the ISO, it was well, we were using Amazon, but back in the days, it was quite, we didn't expect that kind of traffic. I think we ran out of credit on that server in like first few hours or something like that, and we were desperately looking for mirrors. Yes, that was an experience. Okay, so next 2 years, and we got Qubes 2.0 release. The first release where we supported not just Linux VMs, but basically any operating system with HVM support. You could install Windows, you could install FreeBSD, you could install other operating systems. And at that time we had some basic support for Windows integration, but it was not open source, not stable. Well, it's not fully stable yet, but it was very early development. Later we got funding for this Qubes Windows Tools development. It was funded as part of OTF grant, and part of that was making the Qubes Windows Tools open source. And this is how it got developed as open source later. Then we've got Qubes 3.0 release in October 2015, and this is first version where we introduced a hypervisor abstraction layer with an idea that the default setup uses Zen, but you could implement alternative version with some other hypervisor. So right now, we still don't have any officially supported alternative implementation, but there we have tried if this hypervisor abstraction layer works with using Windows kind of isolation mechanisms, some Windows accounts, some Windows mechanism. It proved that the abstraction layer works. We did implement that. It was not never released at as open source, but it also proved that Windows isolation mechanism are not really there. So it worked, but the isolation wasn't really there. As you could expect, it was mostly about various GUI stuff. Even if you have applications from different accounts, from different, I think that was namespaces or something like that. I'm not Windows expert. You still needed to share some global objects, and they were breaking the isolation. And I think today there is also experimental version of Qubes OS with KVM, which is using also this hypervisor abstraction layer. This is just few components you need to implement that are specific to the hypervisor, and there are some that works on KVM. Okay, so the next release was 3.1. It was incremental update over 3.0 with major feature salt stack integration. And this is how the initial setup got some more possibilities. You get not just a predefined set of VMs, static set of VMs, but you actually could choose what do you like to install. There's, for example, default VM got offline by default and stuff like this. By default, this salt stack is not fully used, like the full potential not used in the default setup, but there are several projects that use a lot more of that. For example, Qubes built-in infrastructure is also running on Qubes, and is using, you can set up the whole thing, the several VMs that are involved using salt stack, and the configuration is public. Another thing is the whole secure drop platform. I think we'll learn about that later. Okay, and then we had 3.2 release with several features, but I chose USB path as the primary one. And then we got Qubes 4.0 release in 2018 with major rewrite of the core management stack. It's still written in Python, but it was basically rewritten from scratch. The initial version over those 8 years was there was a lot of technical debt there, I would just say. The funny history is that internally we called it Core 3 because we planned to include that in Qubes 3.0, but it took some more time than anticipated, so we have Qubes 4.0 with something internally called Core 3. Well. And then we had a 4.1 release this year with a major feature of GUI domain. It's an experimental feature. you can use it. It's not really stable yet, and probably won't be stable in 4.2 either. But it is something that we try to do to reduce the number of things running in DOM0. So DOM0 will be very small, very isolated, and will be only about the core management and not some actual application that the user interact with. Okay, so what's about upcoming Qubes 4.2? The general theme of the release is going to be all the stuff that didn't make it into 4.1. And there is a lot of this. First of all, the FW update integration, already Piotr mentioned. This was developed like 2 years ago, something like that. And for a long time it was blocked on a small change to Zen and Linux to access some UEFI table to actually be able to update UEFI firmware. And recently those changes were finished. Well, the initial change was kind of a hack. And now we have a proper implementation, and it is in upstream Zen, and I'm not sure Linux, not yet, but almost there, I think.
Yeah, not yet. I don't know. I'll probably have to resend the patch to make sure somebody looks at it.
Yeah. Yeah. So
this could be carried out of tree if we had to.
Yes, but it's almost there, and I hope to include this in 4.2 by default. Then we'll have I have some slides about specific topics. So the FW update will work similar to Qubes DOM0 update, that it will use update VM to actually download, to interact with the network, with the servers, and the DOM0 part will just instruct what should be downloaded and what and verify what actually was downloaded. And there is a repository with the current code. There are also some tests.
I can add something here. It's already upstream to FWPD repository, so it's already in the FWPD code, and it can be built from that point.
Oh, that's nice.
Okay.
Perfect. Okay, so and there is a diagram how it works. So the when we have the slide. So the DOM0 requests the metadata, then update VM return metadata of the available updates, and DOM0 then choose with specific update to download, and update VM downloads it. Similar thing can be used also with sysUSB to update firmware of any USB connected devices, like whatever you have there. So it's not only the system firmware in DOM0, but also firmware for other devices. Okay. The next feature in Qubes 4.2 is Wayland support in GUI. This will be probably still experimental feature in 4.2, but we will see. So there were two attempts. First attempt was with Schmitte. I'm not sure if I pronounced that correctly.
Smithe is how I pronounce it.
Okay. And the current approach is using WL roots. The GUI protocol handling is written in Rust, and this is almost the first component in Qubes that is written in Rust. And we generally will try to migrate from C to Rust. Slowly, there are a lot of codes and not a lot of expertise in Rust in our team, but we are going there. And I won't talk about much details here because Demi will present a detailed talk about this topic later today, I think. Okay, the next thing is PipeWire. This is similar situation as with Wayland replacing X11, and with PipeWire replacing Pulse Audio. There are several advantages of PipeWire over Pulse Audio, but it's also still compatible with Pulse Audio applications. So it should work like a drop-in replacement. There are still some issues with it, but it mostly works already. And also, Demi will talk about it in a separate talk, so she will cover that topic. Then the next thing is Linux. We have when you install Fedora template. When we install Fedora natively, it comes with Linux enabled by default. But when we install Fedora template on Qubes currently, the Linux is disabled because we have several components that require custom policy to start at all with Linux enabled. And this is what is going to be added to Qubes 4.2 to be able to start to use Fedora and probably other distributions too with Linux enabled. This will allow to sandbox several services. There is, as for the user applications, by default, they are not sandboxed. There is this unconfined user, which is basically do anything. But it is possible to enable limiting sandboxing user applications too, with some issues. There are some challenges, and also when you enable. The current state is that there is a set of pull requests. It's not merged into a repository, but it kind of works already. But when you enable Linux, the root file system of the template needs to actually get labels for the Linux, and this takes some time. It's happening during VM startup. It takes, depending on the hardware, it can be 5 minutes, it can be 10 minutes. When I run it on CI, which is using desktop virtualization, then it took about half an hour. And the VM's startup timeout is a minute. So it's not, there are some challenges here. Yeah. When it got stable, we'll ship templates with labels already in place, but it's still this reliable link stuff need to be handled somehow. We'll work on that. The next thing in 4.2 is a lot of nice GUI applications and GUI interface. Marta will talk about that later. But basically we've got new global settings, much nicer, readable and less overwhelming. And we've integrated QRexec policy editor for some common applications. So this is something, the QRexec policy previously required editing text files with a specific syntax. If you made a typo, loading the whole policy fails and all the calls got refused. This can end up with some funny cases like copy-paste stopped working. So yeah, we definitely need some tool to handle that easily. And also the create new cube dialog got rewritten with also the much nicer interface, much easier to understand. This all was written by Marta, and it was work funded by Prototype Fund, and also Marta will talk about that later with a lot of interesting information about how to design GUI stuff.
With details.
With details. Okay, the next thing that is not going to be very visible to the user, but very much relevant for developers, is Qubes Builder. The current Qubes builder is a set of make files and shell scripts with some small parts in Python, and it's not easy to use, not easy to maintain, and very fragile. This is, for example, the single most important reason why we don't have separate maintainers of individual components, because currently there is very little isolation between individual components, because those are basically make files sourced from one another, and yeah, you have a lot of shell code that is you don't have much control which is executed where and with what environment. So we decided to instead of adding yet another layer with some abstraction or something, to simply rewrite this from scratch. This is a lot of work done by Frédéric. And here written the whole thing from scratch in Python with very similar functionality, but much nicer design, much nicer structure. So you have some actual Python classes and responsible for a single thing and with very limited side effects. All the actions are done in some specific isolated environment. It can be a container, it can be a disposable VM. There are several options, and also Frédéric will talk about that in his talk later today or tomorrow. I don't remember, but probably today. And then we have new tools to install updates. The old tool was based on sound. It was calling this using the stealth integration to install updates in various templates. The good thing about it was that Salt supports a lot of Linux distributions, and not only Linux, theoretically it also supports Windows, and we got multi-distribution support for free. But the bad thing is there are several interaction between Salt server and client. I think in Salt terminology is called master and minion. And this forced us to put some disposable VM in between to do the actual processing, because we don't want any complex processing of some VM originating data in DOM0. So it means when you update the template, you start a disposable VM, you copy Salt configuration into VM, this disposable VM, then this disposable VM start a template and apply updates there. It takes a lot of time, it requires much more memory, and also Salt being a generic tool, is not always very efficient in installing updates. For example, it in some cases it downloads repository metadata several times. In case of Fedora, I think it's about 100 megabytes. On fast internet connection it's not an issue, but on slow it's very noticeable, especially where your actual updates will be, I don't know, 10 megabytes, but you download hundreds of megabytes several times just to get the list of updates. So this is, those are issues with the old updater, and the new updater provides similar functionality, but it's written just as a updater tool, nothing else. So it's also written in Python, and it's currently supports Fedora and Debian. So we are removing Salt from this picture, so we actually need to add support for all the distributions we would like to support. So it's calling DNF on Fedora and apt on Debian. It provides removes this complex data processing that Salt did as a generic tool to do everything. But we still have ability to apply some hotfixes before actually running updates. This was one of the things that we also used in Salt. For example, if there was some issue, some security issue with apt, we could patch apt before actually starting it. And similar for RPM or DNF. I think all of those tools in the history of Qubes got some hotfixes at least once. So we actually use this functionality. And this new tool also provides this ability to inject some hotfixes before other updates. We don't need a disposable VM in between, so it's much quicker. We also we have specific tasks to execute, so the update. So we have much better control what is happening there. Yeah, and also one nice benefit of a specific target tool, we've got progress reporting. So there is a progress bar for installing updates. Yes, so currently it's already merged into a master branch of all the relevant repositories. The GUI integration is not there yet, so the GUI tool is will need to call that tool instead of the old one, but it already works. And this tool was written also from scratch by Piotr, who is also with us here. And the last thing I've chosen for this presentation is update to Zen. It will be Zen for 17 when it gets released in November, I think. And there are several features, some support for newer platforms, some several improvements, but some contributions to Zen are available also upstream already. So this FW update support, and also debug console over USB 3.0. When you get a laptop, it's very hard. You don't have laptops with serial console nowadays. So to get some debug messages when something when Zen crashes and so, is a challenge. So this is mostly for developers useful feature to be able to use USB 3 connected debug console. There's a feature in the USB controller for that. So debugging, for example, suspend issues on laptops will be much easier. There are, of course, several other smaller features. So this is just a set of most important ones. Yeah, but that's the broad overview. Okay. Any questions?
The question with the point with side problem is that it gets dropped sometimes in Debian.
Yes. There's a problem with Salt is that Salt package in Debian is well, maybe not totally not maintained, but it's sometimes in Debian testing it's get dropped because of some issues, and Debian yeah. Yep.
With the hypervisor abstraction layer, how well maintained is the KVM version? I'm just curious because I've heard a little bit about it, but I don't know if it's a very basic question. I don't know very much about it.
So it's alternative implementation. So the official repository do not include that. Okay. So there is a fork of several packages that adds support for KVM, and I'm not really sure how up to date is it, but if you are patient enough, you can build it and. Okay, so thank you.
Hi, hello. My name is Michael. But before I get into like anything in detail, I wanted to say thanks because like as daily users of Qubes OS and Qubes OS focused developers, the SecureDrop team has been looking forward to this weekend since the event was announced. So really, I wanted to express how grateful we are to Invisible Things Lab and also 3M Dev to organize this summit. This is already great and it barely started. I'm totally not nervous to follow Marek, of all people, and I'm totally not jet lagged. And these are not slides that I finished at 7 a.m. and I've not only slept 30 minutes. So yeah, welcome to building secure applications with Qubes OS. Clicker.
It's time for censorship to check.
It's the NSA. To get you an idea of what we're going into, I'm going to tell you a little bit about Freedom of the Press Foundation. I'm going to give you a very quick intro into SecureDrop, and then focus most of my time on the SecureDrop workstation. So, Freedom of the Press Foundation is a US-based non-profit organization whose mission it is to protect, slides are slow, I'm sorry, defend and empower public interest journalism in the 21st century. And for some reason, they pay me to do some stuff with computers. Right. FPF is a relatively small organization, but it does a whole lot. All of these things, but the part of the talk that we care about, again, is the SecureDrop workstation, the very bottom part here, open source software development. So SecureDrop is an online whistleblowing platform hosted on premises by a news organization, and it uses Tor onion services for source anonymity, GPG for encryption, and it's free software and licensed under the AGPL. It's used worldwide by approximately 70 organizations, at least that we know of, but because it's open source, like anybody can set it up, but we do our best to sort of like work with whatever organizations we find out about using this. Ideally, they approach us. And when we work with them, we try to make sure that they configure the system correctly and also use it in a secure manner, because as people here know, using secure stuff, not always that easy. As you can imagine, supporting such a project, listening to its users' needs and like finding ways to make it better, that needs a pretty sweet team, and luckily we got one of those. A couple of us made it here today. Like, if you feel comfortable, raise your hand so that. Yeah, I guess right now we only have two, but there is one more person coming, Julio. Anyway, feel free to like talk to us about this project and all of the crazy things that I'm going to say. Like, we're totally open to ideas, criticisms, all of that. So, before I dive into the core of the talk, it kind of requires a little bit of knowledge about how SecureDrop is used in newsrooms these days. Today, you'll get a little bit of a speedrun version of that, and I hope that the slight delay isn't gonna impact your experience of that too much. So, a SecureDrop instance is made up of two physical servers behind a dedicated hardware firewall. 3MDEP might be nice to hear that one of the devices that we recommend is the APU2. The one is a monitor server that runs OSSEC, like a host-based intrusion detection system, and that monitors the second, much more interesting server, the application server, which hosts two web applications available via Tor onion services. The first one of those is the source interface. It's a public onion service used by whistleblowers to submit messages, documents, whatever they feel like. These submissions are encrypted against the GPG public key, whose corresponding private key is kept in an air-gapped environment. The encrypted submissions are downloaded by a journalist from a Tails-based workstation via a second web application, the journalist interface, that is only available via an authenticated onion service. And also, you need to log in. Not that, we'd only rely on authenticated onion services. So, in order to decrypt and view submissions, though, no matter if it's a short text or a 500 megabyte database dump, journalists must transfer them to the air-gapped environment, a separate computer that we call the secure viewing station. That, ideally, we recommend is kept in a separate room even. That's the thing that has the private GPG key. That entire process, from start to finish, logging in, downloading, etc., that is all manual. Now, that system has been working quite well, arguably anyway, well enough so that occasionally SecureDrop got attention for a news organization sharing that they did receive a particular news story via SecureDrop. For example, what was it? Süddeutsche Zeitung, Credit Suisse leaks. However, there are downsides, and a couple of them are admittedly quite glaring. The time spent merely inspecting submissions, which can be spam, by the way, is significant. Copying files to transfer devices, going to a different room, booting a new machine, entering multiple passphrases, and so on, and then seeing nothing useful is a massive, horrible time sink. The air-gapped machine also runs Tails, and keeping that patched requires that users actively keep track of updates, which, spoiler alerts, sometimes they don't. It also only provides decryption and basic viewing, printing, export options. It doesn't address how submissions are stored. It doesn't take into account how they're shared. So there is plenty of opportunity for security mistakes to creep into journalists' workflows, which, by the way, are more than just looking at stuff and sharing it with other people or printing it. So, in summary, SecureDrop Classic gets the job done, but the usability of the system is quite lacking. This is where Qubes OS enters the picture. For a while now, we've been working on a new system that we call the SecureDrop Workstation. And that replaces the journalist workstation and the secure viewing station, which there should be a chart coming up in a moment. There we go. All of this stuff, including the walking to some other machine. And it replaces it with a single Qubes OS-based multi-VM application that automates the most time-consuming parts of that air-gapped workflow. Demo time. And now there is a short video that I'll narrate a bit. It's an old video. I'm sorry that it's a version from 2020, but it gets the job done. I didn't have time to make a new one. But yeah, this is what you see if you want to log in. You have your username, your passphrase, your two-factor authentication, and when you log in, instead of seeing just, oh, there are messages and these are all GPG encrypted, you will see a client. So that client looks a lot more comfortable. You see that there's like messages that it syncs automatically from the server, kind of like an email client. Messages get decrypted automatically. You can download attachments, and then it gives you the option to like export them or print them or like open them. And if you open such an attachment, that is then, of course, opened in a disposable virtual machine instead of something that could like leave like or cause irreparable harm to your machine. Also, there you see at the very bottom there is a much simpler way to communicate, because previously you had to basically write down the source designation name for a particular source, match it with what you want to answer, and then go to the other room and type that message there into a journalist user interface. Yeah, not great UI, but this one, it's nice. You can tell the source. It's a picture of a kitten in a tree. Yeah. So that's for the demo. And back to
we have a presentation, yeah.
Yep. All right. So demos are cool, and this one might have seemed a little bit trivial, but diagrams are not. And this one shows what's actually going on in the background. First off, the only network virtual machine we have is called SD Proxy, right over there. And it connects via a Unix gateway. All other VMs have no network provider. The client application, right there, runs in a VM called SD App, and it receives its submissions via the proxy VM and they communicate via a QRXEC RPC call. The client, or the SD app, never opens submissions directly. Instead, if you need to export it, or if you want to print it, or open it, these are open in different VMs, respectively. This provides some measure of protection against malicious submissions. The SD-GPG VM, right down here, that is a Vault VM that just keeps the GPG private key, and the SD app VM is the only one that can communicate with that to decrypt the messages. Overall, this provides a sort of like virtual air gap, preserving most of the benefits of a physical one, but reducing the manual overhead. And as you've seen, users don't interact with these VMs directly. Their main point of contact is the client. This makes Secure Workstation accessible to folks who might not otherwise be able to handle Qubes OS workflows manually. So, clearly there's been some thought and also code that was poured into this, so we must have learned some things. And indeed we did, including some things that hurt a little. And this is maybe the part where you can anticipate that I might say some things that might not be received all that well. One of which is the following. Changes to DOM 0 are mandatory. We're starting off with something that's taboo, but some of these things are just how they are. DOM 0 is the only place to install templates. Okay, that's not too controversial, but we also need to create a specific set of pre-configured virtual machines. And at least in our current setup, the order of operation of how they're set up, if you don't want to flood the user with a lot of error message about QRXEC failures, also matters. Now, if we want to leverage the Qube's power while ensuring that it's usable by journalists, that also means that we need to add our own RPC policies to let some inter-VM communication happen without user intervention. While we also want to deny most of the things because our goal is to isolate our VM from mistakes and also like malicious intent. So, installing into anything into DOM 0 requires kind of lead skills. You might already have inferred, but our target audience isn't hackers. Not on the end user side and not on the admin side either. Linux admins that are security conscious enough to have at least tried Qubes before are rare to begin with, but average newsrooms probably have much more experience with macOS and Windows. That can create quite a hurdle because our current installation docs require admins to get workstation RPM packages into DOM 0, for which they have to go through a convoluted process of repeated uses of QVM run at different points in time, and you cannot copy paste. This can all totally be automated, but if you're bootstrapping your project and no one solved this before you end up with instructions that are, not all that fun to follow, even for someone that is experienced with Linux for like 20 years. So a let's do it in the docs attitude is great if you start a project, but as you try to expand your user base, you need to come up with something better. What there wasn't time for during the demo was showing our approach to updates. In order to make sure that all security updates are applied, the client is run via a launcher that also lives in DOM 0. And that one ensures that all the relevant updates to templates and to DOM 0 are applied before users are allowed to log in the first place. I assume most of you have experience with how long updates can take. Marek just talked about it. Now imagine if that was a like user-facing blocking like situation. That's what you're confronted with every day, because every 8 hours we force you to go through that process, and sometimes it can take more than 30 minutes. And as you can imagine, if you have lots of templates, which we used to, the complexity and the like how long that takes just increases. And it can be fairly error prone. We used to have 8 templates. Now we have 6. Now we have 4. 2 of those are our own. Might talk a little bit more about that later. Plus the sysvms templates from Fedora and the Unix gateway. And speaking of error prone, does anybody else see repeated failures when they try to update their Unix gateway? So on a day-to-day basis, if you have to update these things, these compound and are quite painful. But Qubes OS itself presents an unusual UX challenge. I see someone nodding. That's not news to anyone here, I think. But if you're trying to build an application that is this accessible, like, it becomes even more of a, what are we doing here? As an example, non-Qubes OS users might be just expect a device that they attach to their computer to just be available for use. You know, normal computer stuff. That is at odds with Qubes design for good reason. But the very real chance of error when using the device widget, that's real. I attach stuff to the wrong VM on a daily basis. If you don't mess up, hats off, you have really good mouse skills. So to get around that, we kind of break a bit with Qubes idioms, and I'm not too happy about that either, by the way. We add udev rules and scripts to the template, or the app VM, that runs sysUSB to automatically attach USB sticks and printers to a dedicated VM called SD devices. And that has its downsides if you want to use your Qubes OS machine for something else on the workstation, because you want to use USB sticks for something else, and it's like just additional work for that. But it still does reduce user error for something that is as critical as making sure that journalists don't get compromised. The other thing is that the separation that Qubes kind of like brings with it, and that is the great feature of it, that also makes interaction with everyday apps a little bit odd. Normal patterns like printing and saving work don't quite work as expected depending on the context. So in our case, you saw earlier, you open a file, it opens a window for you, now you try to print it. You can't, because the printer isn't connected to the disposable VM that was just spun up for you. If you make changes to that document and save it, those changes are gone as soon as you close the window. That breaks user expectations. We all understand, we here understand why this is the case and kind of like necessary to a certain degree, but a journalist might not. Now, Marek already indicated that I may be talking about SaltStack, and I am, but I don't know. I'm a bit salty. I didn't originally intend to add this, but there was a little bit of a recent incident, and so I decided to go ahead with it anyway. And I don't know. Maybe it's our use of how we do things, or maybe it's just SaltStack itself. You mentioned a couple of issues with it, but it's difficult to debug. And when states fail, sometimes the stuff that you're looking for, you don't see what's going on. It's just hidden. It's annoying if you're trying to develop for that system. It's also not all that, and I can't pronounce that word, idempotent. You know what I mean?
Idempotent?
Idempotent? There you go. Thank you very much. It's not as idempotent as one would hope as soon as you, of course, introduce some command runs. And that happens as soon as your application gets a little bit more complex. The other thing that is an issue for us is because we sort of depend on some VMs to be set up before others, to not show user errors and all of that. Enforcing the order of operation isn't natively supported. So we kind of resort to out-of-band scripting to change VMs, set them up, change them, reboot stuff, and then bring up the others and stuff. It's not great. And what we've also kind of learned repeatedly sometimes is relying on it a little bit too much can bite you. So the incident that I'm talking about, it turns out that very recently and still right now, I think, the workstation is uninstallable because Fedora 36 updated the salt packages, and that introduced a problem with how dump zero can't tell, it doesn't run salt states. I don't know, you can probably explain that better. But we rely on that, so at the moment it doesn't work, but credit where credit's due. This was genuinely awesome. Marek figured out both the cause and the fix within a couple of hours of us reporting this, and I'm totally lying because this screenshot is old. In fact, this is already closed, and I don't know. Thanks again for the quick turnaround. And I don't understand. When do you sleep, Marek?
happens.
That's not often at all.
Okay. This happens to us repeatedly. We highlight an issue and like marks on it like immediately. I don't know. We have regular work days. But yeah, a little bit enough of the kind of like poo-poo content. Let's talk a bit about what lays ahead. And I want to give also a little bit of a disclaimer here. Like, these are things we're still discussing or haven't even as a team discussed in depth. Yeah, you know, the exciting stuff that I hope I'm not going to get in trouble with my team with. So, yeah, we want to maintain more of our own RPC calls. One of those motivations is potentially like VM pipelines. So I mentioned maybe sanitization and like redaction earlier as like examples of workflows that journalists need to do. Those can sometimes be kind of like multi-stage processes. Managing those with like QVM open or the lower level equivalent, like which is how we do things at the moment. Like that's, for me, that's tempting fate. Like there's a fun slide now. There you go. This is what I consider fun, just a Wayland damn meme joke. But yeah, I don't want to end up like this person that like madly tracks like stuff and yeah, just gets real messy. But yeah, at the moment, this is how we do things, but most of what we do is just really straightforward one-off operations, like open this file, export this file, print that thing. And there is some basic two-way communication happening there, but as soon as we introduce more complex stuff there, I think custom RPC calls would likely help us out a bunch to like streamline how they communicate. Also, there's like additional thoughts, like substituting some technologies. One of those ideas, if you're maybe not familiar with it, Sequoia is a Rust implementation of OpenPGP. It has the benefit of being also like very easy to use as a library, and you can narrow your attack surface by only using the stuff that you need. And that is an option for us to replace split GPG, which at the moment is great, but also has seen a couple of QSBs. And I don't know, we don't need to support Thunderbird, so narrowing our attack surface, cool for us. And yeah, for example, mentioned earlier, printing from disposable VMs. That's probably totally a thing that we can also do with our like RPC calls. And I think there's probably some potential where that could be like some Qubes contrib kind of like project, maybe. We'll see. But yeah, earlier in the talk, I mentioned about like, oh, the Tails workflow is like kind of restricted, and maybe you noticed that the workstation's current capabilities, other than immensely improving like the workflow, isn't really that different. So there is no support for sanitization, redaction, archiving, whatever. Some things we definitely do want to cover ourselves. For example, the Danger Zone project recently joined FPF, and Deeplo is here, and who's a core developer on that project now, which is pretty cool. But yeah, if you have news organization specific workflows, that is very common. And at the moment, the only way for them to integrate that is basically fork our project. And that's not really like extensible, that's not pluggable whatsoever. And we don't want to enforce that, but we realize that, yeah, news orgs have workflows and they're gonna have it, so we want to support them and have them able to extend it safely. Like for the stuff that is outside of our own scope.
So what would be the default approach to that? Typically, we'd say like just install stuff in a template. But at least for me, that brings up some worries about template integrity. If we normalize that, it may very well spell disaster down the line. That can be just a regular kind of like software breakage from our enforced like update policy. But if we care so much about isolation as we claim we do, we really should be kind of treating our stuff similar to how DOM 0 is kind of intended to be treated in Qubes OS. So that implies that, yeah, we want to protect against unknowingly or unwittingly compromising the security of our stuff. So, yeah, I don't know. If we still try to make the application extensible, but keep the kind of like don't touch the templates restriction in mind, what can we do? Let's break that down a little. And sorry for the slide delay again. So, yeah, we want to dynamically discover that the client can like trigger a range of different processes, and that the targets of these processes are not required to be maintained by freedom of the press, may be maintained by others. All that while not touching the template that contains the client's code. In other words, we want to do stuff, sounds like remote procedure calls. And what do they target? Other VMs. So leaving the templates untouched? Well, as I mentioned before, we already modified DOM 0 in one way or another and are kind of required to. So extending it with a sort of persistent registry, I know, terrible term, but bear with me. I'm going to replace it in a little bit. That could be really useful for us. So, especially if we also think ahead and then have permutations of how can different RPC calls talk to each other. So, we kind of identified a potential avenue of dealing with that. And that is by utilizing Qubes features. Qubes features is already a generic key value store, but by default it's not readable inside from VMs. Correct me if I'm wrong. That is correct. Happy to hear. However, or that is extensible, and a system that you may already know that uses that is the services architecture. That is a very lightweight way to basically tell a VM, like, you're allowed to start this systemd service. So, we think that we could use the same sort of approach to provide a VM-readable key value store that allows more complex information to be shared persistently across reboots. Like, which target VM supports which RPC call, and what localized human-readable name that action has. So, yeah, and like, what RPCs can be chained in a meaningful way. And at least at the back of my head, there is a little birdie that tells me that could be a great way to minimize our dependence on configuring app VM's disk contents with salt. Just saying. May not run into the problem that we just had. So, when we first started discussing whether we would like to submit a talk, I wondered what's on my wish list. What lower level systems do I wish Qubes OS had or could provide for us to make our jobs easier and the workstation better? Well, I guess I'm kind of happy to report, or sad, I don't know. Turns out my personal wish list barely has anything in it right now. There are some things, we can talk about it later. But Qubes OS already is a super powerful platform for our use case today. QRexec and its policy system are rad as hell. That alone, or they alone, allow for building native multi-VM applications. Now, installing such a multi-VM application is still hard, but that's a solvable problem. And turns out that a lot of the times, solutions to some of the troubles that we're facing may be, quote unquote, discovered in already existing frameworks. So, I don't know what to say other than kind of like, that's pretty cool. And yeah, I don't know. The Secure Workstation began like far before like I joined in mid 2017, and our pilot program with partner organizations started in 2020. That's quite a while, and there's still some work for us to be done, but it's noticeable how great the building blocks of Qubes OS really are. What a huge opportunity they like represent, and personally, I can't wait for more developers to join us in building like more reasonably secure open source multi-VM applications for this platform. Thanks. I don't think there's too much time for questions.
We have time for
there is a
questions.
little bit. Feel free.
Quick question. So it would seem that there's a pretty big, it would seem there's a pretty big risk of accepting submissions from anybody.
Yes.
Is there some methodology within your implementation that can kind of log or somehow track these submissions and validate if somebody is trying to actively attack you, so that you can, I don't know, protect against that somehow?
We don't have any automated systems that try to do that whatsoever, because like it is end-to-end encrypted is not quite the term, but because on the server all the submissions are encrypted and the only easy access to the client is through the client that we're still building. Like we would have to build some heuristics into the client to do these sorts of analyses. At the moment, some news orgs sort of like try to guess whether like someone is just repeatedly trying to spam them and just bring their productivity down. But yeah, there is no automated systems, and at the moment, I'm not even sure that it's on our roadmap even to try to automate that.
Isn't the problem with like a lot of stuff going on in DOM 0? The solution for this is DOM 0 less or admin VMs, or is it this the direction that should be pursued?
Right. So personally, I am interested in using more of the admin VM calls. However, to enable admin VMs, you still need to change some files in DOM 0. So there is kind of like a chicken and egg problem, and like if the like sort of like key value store thing in Qubes features are still there, you still need to sort of like get that somehow. There's probably some way with like admin VMs to do that, or it would be, but at least I'm not aware of that whatsoever. It's yeah, as you know, documentation is hard, and yeah, Qubes OS is a discovery process for us.
I had a bit of trouble following the workflow, like for sanitizing or redacting a document. Isn't that basically the edit in DVM command, where you, or like how does it differ from that?
Right. well, it depends. Like, how much metadata about the source do you want to include, etc. Like, if at the moment the way that we like open a file or like export it is we have a package like a tar file with our own extension, and then in that tar file there is a little bit of metadata as a JSON file, and like dealing with all of that like manually there kind of like feels wrong to me personally. But yeah, I agree. It's like the way that I presented this, like, oh, we want to do this, is super abstract, but that's because like sort of like it's still in early stages of just, hey, let's think about this. Yeah.
We have a contrib repository in Qubes OS.
Yes.
So maybe we can think about providing some meta package that will feed your repository, your keys, that will help bootstrap secure station. Is it something that you will be interested in? Because depending on the policy that we can accept some third-party flavor of Qubes OS, that will probably helps you to just install a contrib repository, then secure repository or something, and you will just call.
Yeah, we're let's put it that way. We're definitely interested in making this a more acceptable use case, and like working with you to like contribute upstream for sure. Especially now when Rust is into it. Nice.
Allows you to. It's a repository that's disabled by default, but the key is already disabled.
Yes, right. Yeah.
Any last question?
So, I noticed there is a potential security risk in with the way you have things set up, and this is one. It's rather obvious. It's not like, but it's the fact that you have you have the user logging into DOM0, and therefore they could do anything. They could do anything they wanted there, which you might not want. So I'm wondering if you've considered, for instance, like having the SD, like having either using perhaps either using sysGUI or you having DOMs or having the SD app be sysGUI or something like that, such that the user only does not have shell access to DOM0.
Personally, totally open to that. The thing is that these technologies are still sort of like in development, and or as far as I understand anyway. And once that becomes like stable enough that we can ship it to like one of the 70 organizations that use our tools, that's definitely some road that we would want to go down, like the more or the less exposure we like have, the better.
Okay.
But
yeah. My understanding, Marek, feel free to correct me, but my understanding is that the main issues with sysGUI is that some of the management stuff doesn't work, and
yes.
sysGUI GPU, there's also hardware issues.
Yeah, sysGUI GPU, it has a lot of hardware compatibility issues, but just sysGUI is it mostly works, but there are some UX challenges like clicking shutdown doesn't work, so stuff like that.
Okay. Yeah. The last time I tried it, and admittedly that's a while ago, there were still quite a lot of like visual glitches, and especially if you deal with kind of like novice users, which we do. I was like, what's wrong with my computer? Stuff is messed up. Like that's not something that would be unusual to hear from.
Okay.
Sure. Yeah. That's experimental still.
Yeah.
Okay, so
Anyway.
thank you for your presentation.
Thank you.
Hi to everyone. So my name is Frédéric. I will talk today about what I did for this past 6 months, something like that. It's about the next Qubes Builder generation. So today, I will just add a few words about the legacy Qubes Builder. So Marek already told you a few words about what was the issues with the current Qubes Builder. So I'm just calling now it legacy. I will present you the next Qubes Builder. You will have some demo, which can be also some tutorial of how you can use it, and we have some question and answer session. So a few words about me. Sorry for the lag between this. I hold a PhD in mathematics. It was a few years ago. I used to model some astrophysics systems, and the point is that I encountered Qubes OS in 2016, and I fall in love into this operating systems. And since I'm working mainly on that, and I love every day I work on that. So, yes, thanks. So legacy Qubes Builder. I'm very sorry for the lag.
You need to switch the slide 10 seconds or 30 before you need it.
Yeah, okay, no problem. I will do that. I won't speak. So Qubes Builder, the legacy one, is the one called you can see here on GitHub, and so it works for now. You can still build Qubes OS as you would have done since years, but as Marek told you, this Qubes Builder is mainly some Makefile and scripts. So what we can do with the Qubes Builder, you can build, of course, packages, you can build templates, and installation image. All is done in one place. You have just one tool to do everything. We also, this is how we release package, and also how we do the development of Qubes OS itself. One problem with that builder is that, for example, when you clone GitHub source, you cannot just say I can use this source as is, and we can use them to produce usable source into other build systems. So this is what I'm just saying at the end. You cannot integrate this GitHub source directly. And we have a single point of failure. So this software has a single point of failure, which is a human, which is called a Marek. Why this is a failure? So this is something I'm already saying that since a few years. We have only one maintainer for all the Qubes components and templates, which is Marek, obviously. So the only guy which can merge something in Qubes OS repository is Marek. And you can think that it's not acceptable because Marek somehow has a burden on his head, so it's too much work, even if he doesn't sleep that much. And I know when Marek is sick because I can sync my work with him, so but not that much. So yeah, the problem with components is that you don't have any isolation. So when you want to build a Qubes component, you pull all the source. And you have some operations of the source that, for example, if you delegate some maintenance to another people, either if it's intentional or not, you can have some compromission because we do some operation on the source which are outside isolation, outside /root, so outside any isolation process. And so, if any source is compromised, all your other components will be compromised. And as I said, you cannot integrate with some handful system like Copper for Fedora, OpenBuild system, which is very useful for building either Debian or other OpenSUSE, of course, other distribution package. So the next generation Qubes Builder, you can find it on GitHub as Qubes Builder v2. So it's for now it will be called like this. If Marek will have a better naming, we will change that. So it's completely written from scratch in Python. We kept the modular aspect. So as Marek said, the main problem now is that you have a lot of inclusion between several Makefiles, etc. But it's also very useful if you want to just, for example, in the case of a Unix template, it's based on the Debian templates, so you just have to include a slight layer of stuff to build your Unix template, and you wanted to do that for any components or etc. Anything, for example, ISO. So also, if you want to build some flavor ISO, you can just change or add new plugins to manage what you want. So the new things compared to previously is that everything that needs to be executed, so everything means every command that you will do on your source to prepare the source, to build the source, sign, etc. So it's a subset of a lot of commands. It will be executed inside what we call a cage. Cage is just a generic name to say it can be a container, it can be a disposable VM, it can be whatever you want. And the cage is executed thanks to an executor. So I will explain you just and I will show you in the demonstration how executor are seen. So as I said, it leverages container or disposable cubes isolation. We plan to add some way to combine executors, like you may want to use a disposable VM for your build, but also inside this disposable VM you will add also container, etc. So having several layers of isolation is also something we might support. So when on the classic pipeline, when you want to build something, either cloning, verifying Git repository, downloading, verifying, rendering, etc. is done inside a dedicated container or a cube VM. So as you can imagine, it can generate a lot of containers and a lot of disposable VM. And the funny thing is that at some few months ago, I raised my hand and said, how many disposable VM we can create in Qubes OS? So I think, Demi, you have the answer. I don't remember, but...
The answer is, I think, 0x7ff0 is the total number of VMs that you could create from, or either that or that minus one is the total number of VMs that can be created in the lifetime of a Qube system.
Yes, so
because after that you run out of Xen XIDs, and because XID reuse turns out to trip all sorts of corner cases all over the system.
Yeah.
We just flat out disallow it, and so after that you have to reboot.
Yeah. Thanks. So we might need to reboot now some Qubes instance when we build components, but we will see. So we just kept the signing, publishing, and uploading process to be executed locally. So when we speak outside the cage, it mostly refers to something executed locally for now, because the singing process also can be put in a dedicated VM, but we assume that the builder itself is at the same level of trust than the singing process. So this is for now just a matter of choice. So the build process consists in several stages. So this is similar to what you will see in the continuous integration architecture. You have the fetch stage, prep, build, sign, publish, and upload. If you don't want to release or publish any repository, we will just stop at the build or sign stage. I forgot to click earlier to don't have the lag. So as I said, you have some plugins to do that will be run inside all the stages, and if you there is a lot. I've just picked a few of them, and all these plugins are responsible to do what they say. For example, source to prepare the source of the underlying distribution, build, etc. And also templates. If you remember, currently you have some dedicated components in Qubes to build templates. But inside these dedicated components, there is a lot of stuff to create CH root, to have some extra stuff. But now we decided to properly create dedicated components only for templates and not managing CH root, etc. This is done in some other plugins. Makefile.builder are the current way to integrate with legacy builder a Qubes component. So this is now changed to have some simple YAML file named the .qubes builder. So if some of you have seen this new file appearing, this is due to the new integration with the new builder. So one of the problems currently with the legacy is that you have this extra file, but also there is a mix with some makefile targets needed. So you have a mix between the builder integration and also the component normal usage of targets that it needs to create the package itself. So we decided to remove, to properly split, what's needed to the builder integration and the component itself. It is defined with several top-level keys, so the YAML file, either the package set, so it's, I hope you can see properly, yes, the footnote, package set, so host to VM, so we changed the DOM0 denomination because as Marek said earlier, we are trying to potentially support other type of hypervisor. So for example, for KVM, it does not make sense to call it DOM0, so we adopt the term of host. And also the top level of this Qubes builder will refer to what the plugins will use as instruction to perform operation. So I'm picking one example, some simple example. As you can see, either for host or VM, you will define for RPM, for Debian or Linux, several build targets. So for RPM, you define where are your spec file, and for Debian and Arch Linux, you define where are your build repository. And from that, the plugins are responsible for building the RPM or Debian and Arch Linux package. We will use this information to know what to do. I'm picking another tricky example. I told you just before that we try to put in one place everything that's needed to manage a component. So here, for the kernel itself, we need to download extra source file. We also need to download extra module and another file for Mac, if I remember. So the Qubes builder file, we just instruct the builder how to get these files, how to check that, verify these files, etc. And for that, again, sorry for the lag. Another example also is for Debian specific steps. You can see that this time you will see in Debian commands here in red. This is specific to Debian only. It means that the source plugin will call this particular command to render the source, because we need to apply some patch. This is only available, as I said, to Debian, because for RPM we don't have this case, so for now we kept that separately. And these arrobas variables, the placeholder, are related to the executor underlying directory definition. I will not enter in detail, but it allows to have some generic instruction. This is the same for builder main configuration. It's a YAML file. It's much more simpler than to have a YAML file than make files. Somehow we can define more complex configuration values, etc. And we support also including several files. So, for example, here is one I try to split in columns. You can see that you define the Git source repository, what distribution you want to build off. You define also the templates. So you have templates, you have the options of the templates, the distribution that is based on, etc. The components, you can also define some particular variable per component, etc. For example, here you can see the executor, which will say that you will use only disposable VM to run every stage. unless that in stage you want to override some value and possibilities. So this is how it helps to, for example, speed up. For example, you can speed up using Docker than using disposable VM, because, as I said, it uses a lot of disposable VM to just run one build. You support also including configuration files, as I said. So this is, I remember the goal of helping Marek to not maintaining all the stuff on himself. And sorry for the lag again. For example, here we can say that for the Qubes manager, we had Marta as maintainer. So sorry if it's not your updated key. I don't remember your key by heart. But also, for example, for canal test, we will accept also my key for maintaining this component. And this is the demo time to explain a bit more how it works. Okay, so the first thing to do is to clone the Qubes Builder v2 repository and then go into. So I've already done that. If you take a look at the root directory, you will see that you have a README. I encourage you to read it carefully, because there is a lot of setup instruction to be done to use this Qubes Builder. And also, you will recognize most part of this demonstration. I provide some explanation of most of the parts of the builder. You have also in this directory some example configs. Here I've used the builder devel 1 to develop the Qubes builder, and also for this demonstration I have just adapted it a little bit. So I'm just showing you the builder configuration used. Here I will just show you an example for the GUIs VM, and also that I will build only Core Vision Xen component, and I'm also setting that the default executor will be Docker. So first thing to do is to call the Qubes Builder tool. So as you can see, you have several options, but mainly the package, the command. So for this demonstration, I will focus on the package 1, which is related to components themselves, and others like template for building templates, repository to manage repositories, like publishing to a given repository, or unpublishing. For example, when you know that package version has been published and is failing, that it's not working, so you want to just remove it from repositories, and you can do that here. You can also manage moving from testing to stable repository. Installer commands manage the ISO creation, and config is useful to parse values inside the builder configuration file. So first thing is to call package. As you can see that the next command available are the stage themselves. There is an extra stage which is called init cache. This extra stage is responsible to create either mock or PipeWire CH routes. It's mostly for speed up builds. So once the CH routes are created and put into cache, we inject them inside all the stages. You have also an alias whole to simply call all the stage except init cache, which is kept separately. So let's start with the fetch stage. As you can see, there is a lot of output, notably that is cloning source and then verifying commits. So when the stage is done, it produce artifacts based on the given component and the given distribution. So here for fetch stage we don't have any specific distribution related content, it's just a generic one. So all these artifacts are located inside the artifact directory here. And then you can see inside this directory that you have a cache folder which is related to everything that will be put in cache, like chroot notably, components, everything related to components build. This file, this is a folder when you have external source files like Linux kernel, etc. Some log files, so mostly all the output that you have on the screen will be put inside a log file. Sources are exactly the component source from Git. So previously in Legacy Qubes Builder it was called Qube source. So this is a similar folder, but inside source directory here we don't add or modify anything unless you are trying to develop something and you are modifying the source files for committing. But this is a separate use case. So if we take a look at components content, you can see that for the given component here that we did something, it was core version, of course. For the given version and for the given distribution, which is here, as I said, it's generic, so we just set it as no distribution, so no dist simply. It has produced for the fetch stage some file here, which has some information. This file says that the clone source has a git hash given here. If there would have been some version tags, then they will have been listed here. And then the Qubes builder internally computes all the files inside the component source hash given here. So it allows to detect any modification or files added that Git would have ignored. So it allows to have a traceability of the source directory. So once we have the fetched source, the next step is to prepare the source according to the distribution here. So here, as I said, I restricted myself to only booleys for the VM package set. So let's call the prep stage. So I remind you that every command needed for a given stage is run in a dedicated cage. So here a cage is simply a Docker container. So inside this container, in order to prepare to create the Debian source packages, source files, we need to, of course, the source directory. And from this source directory and from this created Debian source files, we extracted some information that has provided inside artifact now. So if I show you what's available for this component version, you have now for the booleys distribution at the specific prep stage the Debian source packaging and also some extra artifact files. I will show you the content. Here. So you have mostly part of the fetch stage information here, but you have also the information that you have the given file name of the Debian source packages and also a list of packages. So this is the package that are expected to be built by this Debian source. And there is a specific case that if some packages are not available, for example debug symbol, it might happen that contrary to what we expect, the build phase will have produced nothing. So this package could not exist. So when we try to copy out from the cage of the given stage, so here from the build stage, if we don't detect debug symbol packages, we allow the whole build to not fail. But for example, package. So this is mandatory file. So there is, as I said, only one slight differences is that we allow debug symbol similar for RPM with debug source and debug info to not exist. Once we have the source packages, we have to call the build package, the build stage, like this. You will recognize probably some pbuilder call. So as I prepared earlier the CH root of pbuilder, so in a dedicated cage, it copy inside the build cage here the previously prepared archive, and also it copy in the Debian source files. And from this stage, we expect at the end to be able to copy out, as I said, the list of deb files listed in packages, except if some like debug symbols will not exist, we ignore them. And this is the case here, as you can see. The build reports that we cannot find this particular debug symbol for the deb file, and then we just ignore this case. If now I take a look once again at the artifacts of core vision of the given version, as you can see for the VM Booley's distribution and the build stage artifacts, you will have the source files and also the built Debian package here, and you have in the Debian build file some information of the stage itself. So this will be very similar to the prep one, and except that you can see that in the package list we don't have the Debian file, the missing Debian file. So here we have the exact package list that has been built from the given source file and the given computed source hash. At this stage, you can now sign if you want to create some remote repository. You can sign the packaging. So simply call the sign stage. As I said earlier, we set only the executor for signing, publishing, and uploading to be the local one. Alors, by local one, we mean that we simply use a local temporary directory to execute needed command on the given file. So here we simply copy the Debian packages file to be signed into, we process them, and we copy out, so we simply copy, in fact, locally, the signed files. Then, once you have signed these packages, you can publish them. So the word publish means that you will create locally a repository that is exactly what to be remotely copy, what you have to copy on the remote server. So once you call this phase, this stage, you can see that locally in the artifacts you have some repository publish. And if I show you the content of this directory, you will recognize the tree of Debian repository. So this is typically what could be synced on the deb.qubesos.org because this is exactly the whole Debian repository. Of course, there is only one package here, but this is usable as a Debian repository directly. So this is my last word for this. For these steps, of course, if you have a remote server available, so here in my demonstration I don't have, but you will have to call the upload phase, the stage. In that case, it will simply rsync the content of this artifact repository published to the remote server, and this is notably configurable in your builder configuration file here. You can see that, for example, for the Deb family, the RPM family, you can provide separate remote destination, and also when you create the ISO, you can push them elsewhere. So, as I said, I encourage you to read the README. There is all the steps that you need to do to configure either Docker executor, to configure Qubes executor. There is information of what stage are responsible for, all the plugins, options also as I presented already, and few helpers of how to manage this big CLI, how you can configure GPG for your build, etc. So more details also on the .qubes builder files, etc. That's all for me. Thanks. It's question time now. Oh, I was providing. So any question?
Okay, so thank you for your presentation.
My name is Suhr from Turkey, and I'm going to talk about how Qubes could be tailored for enterprises. And this solution has been developed in collaboration with Invisible Things Labs. As we all know, Windows is the most popular operating system for desktops and also for enterprise. My name is Suhr from Turkey, and I'm going to talk about how Qubes could be tailored for enterprises. And this solution has been developed in collaboration with Invisible Things Labs. As we all know, Windows is the most popular operating system for desktops and also for enterprises. It's the dominant operating system, and therefore it's also one of the most popular attack vectors. In enterprises, it usually comes with an antivirus software and an endpoint protection software, but there are many situations where this is insufficient and the system can be attacked. And therefore, we are trying to combine the usability of Windows and the security of Qubes OS to reach something which is more secure than an ordinary Windows. So this is not suggesting to change the normal Qubes, but think of it more as a Qubes enterprise distribution, which is specific for enterprises with a Windows focus. So the security would obviously be less than an ordinary Qubes, but still higher than an ordinary Windows, something in between. The solution has been developed from a real-life client project of ours and is in a proof of concept stage. The key idea is that all the complexity and flexibility of Qubes is being reduced, and instead it's configured with Windows VM, which is started in full screen mode. So as a user, after login, the only thing, or the first thing the user would see is a Windows system. And the security Qubes brings in is the isolation of this Windows to its environment. And to control this environment, Qubes would bring a widget to control aspects such as a Wi-Fi or a wired network, camera, microphone, and USB drives. And this screen shows, first of all, an ordinary Windows executed in a full screen mode within Qubes. And at the right side, we see this Qubes widget, which now offers a bunch of Wi-Fi networks and Ethernet network. And the concept and look and feel of this Qubes widget is not much different from a network manager within Windows. So the difference is barely recognizable, which means it's a good usability for Windows users. The screen shows a Qubes widget and a selection of USB devices. The concept is similar to the network view. If the user wants to use a specific USB device, it needs to be enabled here first before it's visible to Windows. However, the concept may be new to Windows users because usually USB devices are available right away once they are connected. This is something Windows users would need to learn. This could be further automated by deploying specific device policies, for instance that specific devices or vendors or USB device types are either enabled by default or maybe hidden and not be available here at all, so that this entire dialog becomes more easy to use. The solution comes with malware protection. Usually antivirus scanners are executed on Windows, and there are many cases where these even introduces additional attack vectors. So the antivirus scanner itself had a security flaw which could be exploited. To avoid such additional attack vector, in this solution the virus scanning is executed in a dedicated Qubes VM, and it's executed for USB drives before the USB drive is exposed to the Windows VM. So this means only after a successful scanning of the USB drive it becomes visible to Windows. And we need status information and test results to the user, because especially for larger USB drives, scanning can take a long while, minutes, maybe even hours, or there are negative test results which needs to be dealt with, such as a virus has been found. Control is not necessary, especially enterprises may not want the user to control this malware protection, because it could allow to cancel the antivirus scanning, which may not be an option. Therefore, we would recommend this as a status and information usage, which is shown here. After scanning, we see the USB drive D, and at the top we have messages from the Qubes widget. Authentication is performed in several steps. During the boot process, first of all, the full disk encryption of Qubes needs to be unlocked either through by entering a passphrase or by using a two-factor authentication device such as NitroKey FIDO2. This is not much different from using Windows with BitLocker. Then the second step is the user authentication, which again is not much different from Windows, but here the user authentication is executed in Qubes before accessing the Windows. And again, NitroKey FIDO2 device can be used as a two-factor authentication method. And only after this successful user authentication in Qubes, the Windows is being accessed. And it can be configured as auto-login, so that we don't have another authentication, or there could be a third authentication against an Active Directory, even within Windows. Also, biometrics would be an option, but we suggest to avoid this for security reasons. Next is centralized management, which is a crucial requirement for enterprises. Say enterprise has 100 of computers to manage, so this then needs to be something like a centralized management system. And this system would consist of, most importantly, configuration management to configure networks, maybe Wi-Fi passwords, devices, endpoint protection rules, as shown before. Also to collect logs and status information of the computers in the field, and maybe to perform activities such as remote password reset, or disk encryption management, or remote data wiping. Naturally, the solution could be implemented separately, or it could be even integrated into an existing Active Directory environment for easier manageability. And another crucial factor are skills. So this presentation demonstrated that the usability for the actual user is very similar. It's not much more complicated. For the IT staff, which is responsible to manage dozens or hundreds of computers, it is a different topic. They would usually need to be trained for Qubes in particular, but if the IT staff is a Windows-focused IT staff, they would also need to learn some Linux topics, especially if they perhaps want to operate their own update server. So in summary, what this solution achieves is an increased security compared to an ordinary Windows system, and still very good usability for the users. And we keep compatibility to Windows applications, which is a showstopper or a strong requirement for many enterprises. We have a manageable solution, which is also crucial, but keep in mind to train the IT staff. Since I can't attend the event in person, please feel free to send your questions or ideas, feedback to us, and start a discussion.
All right, so I'm Marta Marczykowska-Górecka, Marta on GitHub, and I'm doing Qubes interfaces, which is an adventure because we have a problem, and it's not just Qubes. We have a big problem. Wait, how does it work? Oh, it works. Okay. We have a big problem with usability, with design, with making things accessible for people in all sorts of open source software. Qubes is just a very good example. There are various sides of this problem. For example, it's super hard to discover that you can do stuff. If you haven't heard about split GPG, even Google, well, that's DuckDuckGo actually, but never mind, it will not suggest you to look for it. The tools that we have are very nice for people who already know what's there. They're super, super useful. If you basically know all the options, maybe you wrote them, that helps. It's very easy to pass if you know exactly what to expect. But if you are a normal person, yeah, that settings window is kind of a nightmare. It's very scary. And also, a lot of documentation just gives you command line solutions because, of course, that's very easy for everyone to use. And I'm sure it's very easy for everyone to use that's in this room. But we are not precisely a representative sample of Qubes users, at least so I think. I do have a rule when making tools that if I cannot figure it out by myself, and I've been using Qubes for a while, and I have to ask Marek, then probably something is a bit too difficult. And there's a lot of things that are a bit too difficult. It is a big problem in general open source, and I want to talk for a second about why this is a problem and how this problem actually doesn't like me, okay, and why this problem happens. Because I think it's a big barrier in making open source more mainstream, in making open source something that everybody uses, not just a bunch of nerds. Because at this point, if you want to do simple, easy things, well, you can use LibreOffice. It's very convenient. But if I want to do something, the amount of time I spend just like searching among those buttons to find the one that does what I want is very long. Linux is also very powerful. If you Google it, then you can get, for example, 5 helpful commands to check for disk space. This is not something that most people want to do. They want to be able to do it easily. And of course, there are some nightmares like Vim with the eternal how to exit Vim jokes. Also, lots of fun. I loved it in high school, but maybe this is not what we want to do for usability. Because as open source developers, we often have this problem. Who are we making things for? Are we making them for people who will be using them? Are we making them just for ourselves? Are we making them for other developers? This idea that we have of users is often, well, the theory is always very nice. Like Qubes' website has this beautiful phrase that went, made to support vulnerable users and power users alike, and I like this idea, it's a great idea. But is it in practice so? Is this what is the current state what the vulnerable users and not power users can use? I don't think so. And part of the problem is that we have a very, very, very strange idea of what people using Qubes are like. When I was preparing this presentation, I was talking with some other Qubes developers, and a very nice conversation arose when I posited a point and somebody said, oh, but people on Hacker News constantly say something contrary. Yeah, but maybe people on Hacker News are not exactly the representative population of our users. This is the problem of completely overestimating the skills of normal people, and of course there's a helpful XKCD for this, as there always is. I've done a survey of Qubes users, partially with help of Nina Alter from SecureDrop, who is unfortunately no longer working with us, but who did a lot of great work. And it turned out that 70%, 65% of people actually wanted to use also graphical tools for configuring stuff. And 27% of users, of actual Qubes users, actually prefer just to use graphical tools. They don't want to use command line. Well, sometimes they have, but they don't want to. And the people we are usually developing for are the people who prefer the command line. This does not work well. There are several problems that arise from this focus on the experts and not on normal users. And the classical example, and an example that I hope will be more familiar to all of you than Qubes interfaces, which are very friendly for us because we know them, is taxes. When I first opened the German tax software, the Elster official one, I was like, oh no, that's bad. I don't like it. I don't know what to do because I'm not a tax expert. The friendly, pleasant, super easy paid software that allows me to fill in my taxes just by clicking here and telling, okay, I earned this much, just put it in the right places, please. This is what people want to use, what most people want to use, because the scary software is scary, it's confusing, it takes a lot of time to visually pass it. And Qubes is a lot like this super scary tax program for experts, and much less like the pleasant program for non-expert users. For example, we can see here the evolution of Qubes global settings from the only slightly scary window to this beautiful and utterly terrifying window full of combo boxes, combo boxes, combo boxes. We often have this problem, this like fear of emptiness. We are afraid of the vacuum. We don't want to waste any space, just like put all the options there, which is also very nice when you know where they are and what they do. Not very nice when you are just looking for something and aren't yet familiar with them. Needs of people who are experienced are very different from the needs of typical everyday users, from people whose hobby is not tinkering with computers. This is generally a big design problem because humans are, I have it on good authority, I even studied psychology, humans are not computers. They don't really work like computers. And developing good user interfaces requires different skills from programming. And when people who are very good at programming design interfaces without those design skills concerned with humans, we have troubles like the LibreOffice versus Microsoft Office window. It's much easier to find the things you need in Microsoft Office because it's geared towards humans. It has a lot of words, a lot of empty spaces, everything's sorted. It takes more time to use it if you are a super expert and know every button, but most people don't actually know every button. And people who know every button probably can easily learn shortcuts. Also, there is the big culture problem among developers. We are, how to say it, we are not very nice about people who don't know what they're doing. We just want everybody to be like us, to love tinkering, to easily figure out command line stuff. The user experience part is the annoying part. You just want to do the fun code and the UX is, okay, well, we have to do it. And also user research is difficult, it's time consuming, and you need skills to do it. You need to talk to actual humans, nobody likes that. You probably should actually talk to humans, oops, is that my fault? That's not my fault, I hope. You probably should also talk to humans who are not in your core community, not just people here, not just people on big tech conferences, talk to normal people. That's why we did a survey of Qubes users, and a lot of people agreed to cooperate with us. A lot of people agreed to interviews to tell us what are the real problems, what is actually difficult, what is confusing. Because from the point of view of someone extremely used to the software, things look a bit different. And as I've said, the big problems that I've seen during my user research, during the interviews with users, was that in the existing graphical tools, there's just too much Too much at the same time, too much options, not enough explanations. There is a lot of things like, for example, okay, what is DOM0 updates? What does this mean? Which you have to click on the combo box, read the options, and then you're okay. So this is like the source of DOM0 updates. Okay, that's what it is. For many people, it's like additional DOM0 memory. Do I need to use it? What is this? Should I use it? Should I put something there? It's very much on top. This looks important. Should I change it? Maybe I shouldn't change it. Who knows? This is not friendly. This is not helpful. Another pain point that I've discovered were policy files, because they are very simple in theory. We have very nice blog posts explaining them, but using them in practice turned out to be very difficult, especially as, for example, there are subtleties. If you're using certain services, you probably should be using parameters for the allow and ask actions. For other services, they don't make much sense. Sometimes argument is important, sometimes isn't. You have to find that information in multiple places, sometimes just by reading code. This is not helpful. And another thing that confused people a lot was the new cube window, because it's also a tiny window, bunch of options. You feel like maybe you shouldn't change some of them, or maybe you should, because they can be very confusing. A while ago, for example, we added explanations that say that, for example, new disk VM has no persistent root and no persistent something, and people are like, I have no idea what this means. There are words. They look smart. So I've decided to redesign a bunch of those things. This work was funded by Prototype Fund and the German Ministry of Research and Education. And the first thing I redesigned was the new cube window. Now, the biggest thing I wanted was just to explain what options actually mean. If you see any spelling errors, please let me know. This is not yet merged. It's still awaiting review. So yes, we can fix spelling errors. And I know that for many people this looks annoying. This looks like, why are you wasting so much space? There is so much white space here. But if you know what you're doing, you can use QVM create and achieve the same results. If you don't know what you're doing, now you can read what the options actually mean. Now you can see things like, this can be changed later here, which is also an important part because people aren't always sure. Okay, if I change the option, can I change it later? Or do I need to make a good decision right now? Is it important? There is also a lot of tooltips, a lot of words, basically. Because it turns out humans like words. Pictures too, but words are really, really nice for explaining complicated stuff. Another problem that's often with Qubes tools, you see all the options all of the time, because you may need some of them. So now I hide certain options when they're not useful. For example, I have this window, this like part for choosing which applications will be in the menu for the created cube. If you are not cloning, if you're just making an empty standalone cube, you don't get it because we don't know what applications will be there. So I'm trying not to show things that will be confusing, that don't apply, because you don't want to make people think. One of the most important books in user interface design is called Don't Make Me Think. And this is a good approach. Hide everything that makes people think unnecessarily. People don't want to think. Thinking is time-consuming. Thinking isn't pleasant. And most of us just want to think about things we find fun and not about everything. I've also redesigned the global settings and merged the original scary window with a bunch of stuff for editing policy. And my goals were, again, more explanations, more words, information that, for example, you will need to restart stuff to see the changes. Because when I was testing the existing settings, global settings, I realized, okay, some changes don't actually show until I restart the cube. So how can people know if it's working as designed or if it's a bug? Because bugs happen. So more words, more words, more words. Sorry, we have a bit of a lag. Something, of course, should not be super easy. This is especially important in cases such as Qubes, because Qubes is complicated, and Qubes is often complicated by design, because we don't want to help people hurt themselves. And some things are complicated because if you change them, things may possibly explode or be complicated. So for example, if you change the cube to which you attach your USB controller, you probably have to change a lot of stuff. So those things, they need more clicks. I know, terrible. Why would you make people click more? But it's good. We don't want to make such things easy. We also add a lot of text to make it scary. Don't do this if you don't know what you're doing. Sometimes more explanations, sometimes making things a bit scary, a bit more words is also good because it makes people think a bit more if they want to change something. And also, I am exposing a bunch of things here that only were up until now available through editing policy files, which is an adventure and can easily lead to fun problems such as, oh no, I've made a spelling error and now I can't copy anything. What's wrong? I wasn't editing that, so now this hopefully should not happen. And I'm trying also to give some more explanation why would you want to change certain options. For example, if you want to allow USB keyboard, I'm trying to explain to the users why they would want to allow it, because actually a lot of people aren't sure. For example, is my laptop keyboard a USB keyboard? That's a good question.
Design dependent.
Yes, I mean that's a problem. That's a problem. That's
Mac laptops have USB keyboards.
Yes, it's terrible.
Kind of.
Yeah, but I'm not sure if you can install Qubes on a Mac.
Just.
Yeah, I know, but this is also
problem.
This is a problem because everything is so complex.
Typically, you have PS2, but it's not a general.
Yeah, but how many people have PS2 keyboards nowadays?
Isn't it by now recognized during the install that you're using USB? So
Yeah, but you can also change it in the future. You can add a USB keyboard and have this huge confusing moment. Okay, if I add a USB keyboard to my normal computer, everything works, but I connect it to my Qubes laptop and it doesn't work. What do I do now? So we want to have more options about it. I'm also trying to expose some options, possibilities that a lot of people have never even heard about. I've done for this project over a dozen in-depth interviews, and it turned out that most people have never heard that Qubes has Qubes U2F proxy. Even people who use devices like that, they're like, oh, interesting, that's fun, I like it. Why have I never heard about it? Well, probably because you don't read documentation as a hobby. Because that's the place where it's the easiest to find that information. At least now, you still have to do some stuff to use it. So I'm telling people, okay, you have to use a package. Click here on the link to read documentation. It will open it in disposable VM, of course. So there is still a moment where there can be a failure if they don't have enough memory, but we don't want to have a web browser in DOM 0. That would be a bad idea. Anyway, I'm trying to expose those options to tell people about them, because it turns out a lot of people have just no idea what they can do, and not all policy settings will be covered by this design. Not everything will be possible, because this is another trap that we often fall into. If we can't give user a graphical interface to do absolutely everything, why bother? Well, because 85–95% of needs of actual most users can be covered by simpler interfaces. And the super difficult 5%, well, if people have to use command line for the super complicated cases, I think it's not that big a price to pay if most cases are covered by friendlier tools. Because this is the same as with, for example, I don't know, power tools. Simple tool that can do everything is probably not very good, but it's enough for normal home use. But if you have a workshop, you probably need a lot of dedicated tools. It's the same. We want to provide as graphical tools to simple tools for simple cases. I also want to do something that's missing in many current Qubes settings tools explicitly say a bit about what's actual default, what will happen if you don't set anything. Because, for example, for checking for updates, the current global settings windows was a bit scary. So now I'm telling it explicitly. That's what it happens. New Qubes will, by default, check for updates. We also want to, as I said, also want to show some things, for example, that split GPG exists. Because another thing, some people have never heard about it. They've just downloaded Qubes, it's cool, but to use split GPG you have to manually install a package and you have to know about it, and this is not easy. We are not Microsoft to spam you with big windows like, did you want to install that? But still, we want to have some way of telling people, hey, maybe this is what you need, maybe this is what you want. Again, as you can see, there's a lot of words, it's a lot of pages, and I know it may feel like, oh no, people have to click on so many things to actually do what they want. But the mental load of first finding something in the menu that has a limited number of options, then looking at the structured text with white spaces, with headlines, is the overhead of this action is actually lower than looking in a big window full of every single combo box you can think of. Again, it's harder if you really know really well what you're looking for. But settings is not exactly a place that most people know what they're looking for so precisely. And the people who know so well what they're looking for probably will just write those files by hand because it's going to be easier for them. I don't expect Marek to be using this tool. Because it's...
I will use it.
Thank you, I'm very glad, but I'm not sure if it's not just because you like me. I'm also, okay, please go to next slide. I also want to give some examples to people because again, because discoverability in Qubes is so bad, I want to, for example, tell people, I don't know if you can see, but give examples. Okay, for moving and copying files, you can use options in the file manager, but also QVM copy, QVM move, because not everybody knows it. Not everybody knows how to move files across Qubes. People sometimes, one user that I interviewed had this like, he figured out that he can do it in file manager, in one of file managers, so he thought that this is the only way to do it, just right-clicking in the file manager and moving one file per command, because that's how it worked for him. Because it's difficult to discover easy ways of doing things. I will also give, like, everything here, all the policy stuff in this config manager is based on a separate set of policy files, so if you really want, you can edit them as you want. I expose them. If you want to mess things up, go ahead. I mean, we can have fun with those policy files, and it's perfectly okay, but not everybody has to do it. Now people will be able to just click on things. And I also want to provide a very simple thing that actually a lot of people really wanted, because they wanted to be able to answer questions such as, how much RAM do I actually have? Not everybody knows the specifications of their laptop just, just like that, just at every time. Nobody knows exactly, okay, what model is my laptop? I have no idea. It's a laptop, I bought it. Probably a good one, I hope so, it works. So I want to expose that information also because it's nice when people can actually tell us when something's not working, what is the hardware they're using. So yes, that's the redesign. Hopefully it will come in Qubes 4.2 when we review it and Marek stops telling me all the things I've done wrong. As I've said, it was funded by Prototype Fund. And yes, I hope to be doing more redesigns and improvements of Qubes user experience because I think Qubes is great, but extremely opaque to normal people, and I want to make it great for, well, I don't want to achieve the level of every grandma can use it, but I would like to achieve the level of every working person who uses computers normally probably can use it. That would be nice in 10 years' time or something. Thank you very much, and if anybody has questions.
With the system information thing,
Mm-hmm.
awesome. Are you thinking or considering to also integrate the hardware compatibility report, like so that user doesn't need to use a command line in order to?
Oh, I like this idea. I have not thought about it, but I like this idea. So I think the answer would be no 5 seconds ago, and now it's yes.
Go ahead. Have you thought of what for the this device one? Would it be instead of having people run those commands, like for both of those commands, would it be useful to have a button that just ran the command and showed its output?
Yep. And this is something I want to do, like in a future, not very far in the future update, so that you can click those and run the command.
And also, what about one that shows like if your device is like still supported, or if like your device has like is like, for instance, didn't get the latest microcode updates or something because Intel decides your processor you need to buy a new processor from them.
That could be interesting. I have to think about it, how to do it well, but yeah, that could be interesting.
What is the question?
Sorry. A lot of questions. Okay, maybe let's start from the left side, because I think you raised the hand earlier.
Thinking of non-technical users, if you are going to target them somehow, I think the most important thing, or at least it seems to me, when configuring Qubes, is to compartmentalize the operating system properly, and I think it's not an easy task for a non-technical user. Do you have any plans to somehow guide users into
Actually,
this
Diplo, that's making a very good tutorial for Qubes, is touching on those things, and there will be a presentation on that.
Great.
Not only a private joke, but have you considered to write HTML and JavaScript giants? No, I have a justification for that. If you take a look at VMware vCenter or stuff like that, OpenStack, they are using mostly just HTML.
Yeah, I mean, if we will be doing more like remote management, probably that may be useful at one point, although I have to say, I have yet in my life avoided working with too much with websites, and I hope to continue that streak, but we'll see what will happen.
What technology are you using?
It's Python GTK.
Okay. You can even a remote management thing can still be a desktop app.
But it's almost like web. Design of UIs and stuff.
Yes, but it's not the same as designing for the web. Yes, but it's not the same as designing for websites, and it's often something we have to think. Yep.
Two questions. First question, is it possible to easily share the system information? Because it's in DOM 0, so how should I share information what's on my system? Should I take picture with phone, or is there already some?
I mean, there is a button to copy from DOM 0 to clipboard. And maybe it's a good idea, you're right, maybe it's a good idea to add that button there, to just copy to clipboard.
And then you're able just to ask what to do with that. And the second question, do you already design it in the way to include translations in the future? If you're saying about...
Yeah, I mean, GTK is very friendly about that, so yes.
So that's great.
Yep.
So how is the situation about, like, you create the policies via the GUI, but when you back it up, it's not included, I think, on the backup. Are there...
Well, I don't know how it works for backups, to be honest.
Just copy this one directory.
With command line.
Okay, so you're saying that before redesign devices widget, we should also redesign backups, like the whole backup experience.
Yeah, I think we need to copy that directory by default.
Yes, yeah, I think policy is something that we should.
So that they're not like 100 gigabytes each time.
So definitely there will be like a lot of feature requests.
Oh yeah.
So I'm already looking for, like Marek mentioned something about exposing security. status, like secure boot
Yeah.
or some I don't know PCR 0 value or whatever.
Yeah, this is, and I've tried to make it expandable enough so that it's easy to add more stuff. Both design-wise, because this is a sort of view that you can add more tabs and not add to one big screen of combo boxes, but also code-wise.
Business-wise, maybe even saying like this is certified device, yeah?
Yes.
Yeah, definitely.
This is the level of security you get.
We have a lot of settings that affects your system security that are not easy to discover, that they do affect your system security.
Yeah, and this is something that we should probably report on.
Okay, last question.
I don't know. Okay, Frédéric, you already asked your questions, so.
Yeah, I love the QRXEC policy editor. But it was only for moving files, right?
Oh, it's for every single. I just showed. I just showed it in one place for clarity of screenshots.
Okay, so there will be like for
everywhere you can click on edit raw file. Almost everywhere, except for the input devices, because this is just allow deny.
Okay, so and this is the new QRXEC editor that was mentioned in the previous talk.
Yes.
Yeah. Okay. Great.
Yeah, it was not clear, Marek, if all these things going to 4.2, if all these things going to 4.2, or this is like some going and some not going.
I hope all.
Yeah, this should all come. This should all come.
Hopefully 4.2 will be out in a reasonable amount of time.
That's another question.
Yeah, that's supposed to be just one question.
If it does not land, then you will still have to use vmans. But most people do not know how to exit from that.
Exactly. Although one of my cats know how to exit them. So we know.
Yeah, anyway, this is like great work. Like it's like Qubes need that.
Yeah, I do agree. All right.
Thank you for your presentation.
All right, so hey everyone, I'm Arthur from ArcCompute. For you guys that already know me, it's good to finally meet you in person, Marek, everybody else. And yeah, so we're a company based in Toronto, Ontario, and we, for the most part, do a lot of cloud service related things, but we've recently started open sourcing a lot of our software. So we also have another part of our business, we're just calling it the OpenMDev project, is we're taking mediated device software and we're largely making it open source. So we're taking all the bits that are necessary to create mediated GPUs, which are basically sort of virtual GPUs, vGPUs, and we're basically making it all GPL-v2. So we do have a very active community. For those of you who don't like non-free software, you might be upset to hear that a lot of them are in Discord. But you know, many of them are. We're looking at maybe bridging into IRC and Matrix and that kind of thing. And we have a lot of open documentation on how all these things work, graphics, that kind of thing, and a website, openmdev.io. So can I switch here? Or?
Yes.
Yeah.
Is this famous slide?
Oh, yeah. So anyway, I've got a big, long slide of people here to thank, which I'm hoping will come up in a second or two. The first actually is a guy, Rich Prasad. He's the guy behind, I think, one of the people behind OpenXT, who originally kind of pushed us to make a lot of these things open source. Demi, obviously, you've been fantastic in helping and encouraging and helping me learn new things. Daniel P. Smith, who's not here, but also is one of the core people behind Trenchboot and OpenXT, also very helpful. Andrew Cooper, who's obviously one of the core folks on Zen. Really pushing me to learn quite a few things. Marek, who's right there, obviously. Been also quite helpful. Unknown/bin, somebody from our community. Jeffrey McRae Gniff, he's a guy behind Looking Glass. Wendell Wilson, NeoGea, and Kriti Wankid from NVIDIA. Gerd Hoffman from Red Hat. Alex Williamson from Red Hat. Krutov Shaw, one of the creators of something called vGPU Unlock, which at one point was involved in a lot of what we were doing, still is to some extent. Dual Coder, Matthew Vilker, Kenny CH, Grand, Aaron, Ricey, Paulo Loco, and Lil Pingu, all members of our community who have been vital in making all this stuff work. So the first thing that I should have you do before I go into this is a lot of the things that I'm about to show you are constructing on other people's work. So you should definitely check out the following talks if you'd like to learn more in terms of the foundations of these kinds of things. So Alex Williamson from Red Hat, an introduction to PCI device assignment with VFIO. NeoGea and Kriti Wankid's vGPU and KVM VFIO-based framework. Zai Wang's Intel GBTG from production to upstream from Zen Summit. Kevin Tan's scalable I/O virtualization from KVM Forum. Zhang Jiang, sorry if I'm pronouncing these wrong, and Ken Zhu, live migration support for GPUs with SROV from KVM Forum. So what I'm going to be talking about here today is something we're calling GVM, it's a GPU virtual machine. So it's intended in a way to be kind of a KVM for GPUs. As you know, many of you probably know, virtualization of GPUs has been largely locked out to like so-called enterprise GPUs, most of which are, you know, you have to pay to actually use your own GPU in addition to having to need special hardware for it. And it's all closed source and you know, it's not an excellent experience. There are other things like Virgil, which have kind of allowed you to do OpenGL and guests, so you're very limited in terms of the APIs that you can use, and there's a pretty significant overhead. So what we're doing is slightly different. So the main thing is GVM is not reliant on hardware virtualization assistance. So in effect, if you have a GPU that does not provide any assistance, it's like a consumer GPU, this will work just fine. Guests run unmodified GPU drivers, so they're not para-virtualized. You don't need a special driver in the guest in order to make anything like here work. We are using the GPU's GMMU controller. It's an MMU controller inside of the GPU to enforce I/O virtual address translation. So the idea behind that is that if you obviously have an I/O virtual address for RAM, you obviously don't want people to be able to run their address space or make a request outside of what's allotted to them. In the GPU, we have shadow pages. So all the guests get their own sort of page tables, and the GMMU in the actual graphics chip enforces the I/O virtual address separation. And obviously that's the same for MMIO windows on the host, where if you have an MMIO window in RAM, the MMU controller also controls that. So in this case, because we're running unmodified GPU drivers, we have the ability to accelerate through a number of very common APIs, so DirectX, OpenGL, and Vulkan. With Virgil, obviously you have the limitation of not being able to run any of the proprietary APIs, or I'm not sure the status of Vulkan currently in that. But yeah, obviously unmodified drivers. So the other thing is GVM is free open source software based on C. Originally it was Haskell. So our CTO here, Michael, loves Haskell. But we came to realize pretty quickly that not very many people program in Haskell, so we kind of needed to bring things into the, sort of the standards that people are used to dealing with.
700 gigabyte.
Oh yeah, and we had a build task that took about 700 gigabytes, so we figured we'd maybe fix that. So yeah, so this is we have had in the past a sort of separate QEMU management layer. Some people have asked, is GVM specific to that? It's not at all, because we're using the mediated core that's in the Linux kernel. This will work with libvirt, virt manager, virsh, libvfio, anything you want. It's not at all specific to a particular management layer. So the other aspect of this is this does work today with KVM. And we've looked at Zen to try to make it work in that context, because obviously one of the use cases here is Qubes security by compartmentalization, and that seems to be really heavily built on Zen. There are some things around IOMMU groups that we would probably like to resolve, but obviously it might not necessarily be required because there are some alternatives, but we can get into that a little bit more later. So this slide, when it eventually comes up, I found this really useful. This is from the Zen project wiki. There it is. So where we are today with GPUs, if you recall like the history of the Xeno servers project from Cambridge University, my understanding was there were some people there who were researchers who built a method to virtualize the CPU, which was it did not require any kind of hardware assistance. So those were PV guests. So where we are today is basically at this PV guest layer. So it's similar to how Zen was able to enable that without hardware assistance. There are GPUs, some of which use this. So that would be the equivalent of like HVM. They use things like scalable I/O virtualization and SRIOV. Those features, obviously the vendors, in some cases they enable them, in some cases they don't enable them. But in the case of GVM, there's no specific requirement at all that those I/O virtualization hardware assistance layers be there. We can use them if they're there, but if they're not there, it's no problem. So getting to the next slide. When it comes up, this is a big, complicated feature matrix that we could probably visually consolidate somehow, but I'll try to break it down a little bit. So this is sort of a vendor breakdown of all the different devices that have some degree of compatibility with different things. libvfio is a piece of software that we have that will use GVM, but it doesn't necessarily, it's not, again, required to use GVM. This is the compatibility for GVM. So we have, I think, Maxwell up to Turing, and we have some Ampere devices, and we're working on other Ampere devices from NVIDIA. With libvfio, we have all Intel. We have some AMD and all NVIDIA, except for the RTX 30 series, which we're working on. So this is an important area here. So these are virtual I/O assistance modes. So in that scenario, we have, you can see VFIO mediated device, or MDEV. That is pretty much supported across the board. It's a Linux kernel module. It's the mediated core in Linux. That thing basically is what's needed. You can virtualize any I/O device pretty much using this. It allows you to create like virtual bars or base address registers. You can effectively emulate a device to the point where any kind of I/O interaction can occur through the kernel just using software. If you're talking about SRIOV, the device needs effectively an SRIOV switch in the device that you can talk to. Most GPUs have one. Most of them are disabled in firmware because the vendors like to lock out certain features. In some cases, you can basically flip them on. Like there was a AMD device, you can flash a bit of firmware, turn it on. If you can do it, sure, GVM will take advantage of it. But again, if it's not there, we don't need it. Okay, so here's a bit about the internals once it eventually flips over. So guests, yeah, so there we go. So guests, they basically see host-mediated base address registers. So the registers, the way that they get presented to the guest, they're a mix of hardware and of software created base address registers. So what you basically see from the perspective of the guest is a PCI device. Their config space, so bar 0, that effectively is created by the host. So it's a little piece of software that, when you read into the bit config space, the hypervisor traps those instructions and then passes in like a virtualized config space So then obviously we consider that like the slow path. And then bar 1 is actually just like a straight pass-through, or obviously it depends on the hardware vendor. Some vendors will implement something that's completely emulated. Other vendors will implement one that's basically a straight pass-through. So that's all the fast pass stuff. Yeah, so anyway, this is also the other thing is VFIO is responsible for whenever you hit a region inside of bar 1 or any other space that actually has a physical address, so not an IO virtual address. VFIO is responsible for trapping any of those calls and then basically passing in the guest address, so it's an IO virtual address rather than the physical address. Just a side note on this. This is also why a lot of people, when they've asked questions, why does things like NV switch in NVIDIA or like PCI, is it called, what is that thing, SLI? Yeah, SLI. These are like things where you combine GPUs together inside of a guest. A lot of people have asked why those things don't really work. It's because all the translation has to occur through the MMU in order that you can get the device peering working properly. So that's something that's still, I think, actively being worked on by Red Hat. This is a little bit more. Yeah, this is something I discussed a second ago when it eventually comes up, which is reading from the emulated regions. Bar 0 config space triggers a VM exit. VFIO traps and emulates and reads these regions. Yep. And then there's virtual display plugins. So we'll get into the virtual display plugins in a second. This is configuration. So this is typically how we do configuration. The previous conventions, this is an ETC, GVM, MDEV GPU, generate vGPU types.yaml. That was the past convention. We've since moved to TOML because members of our community are doing, it looks like automated stuff where they want, there's some things wrong with like white space parsing or something in YAML, so they prefer TOML. We've moved to that. The problem is many of these things get set on boot because we have a systemd service that goes in, gets that file, and sets all the mediated types. Some people have asked, could we do things where we actually have the types set at runtime? So for example, could we go in and pass in, like, I want a virtual GPU of this size to be available in the mediated types, and do that at runtime without necessarily having to sort of set it all on boot and then go back and change context later. Can I switch? Here we go. When this eventually switches, do we have to do something to play the GIF?
I have no idea, but you can share it.
Oh, did I switch back or?
Yeah. Try to switch back.
Okay. I could just do a live demo too.
Okay.
Okay, let's just do a live demo.
So let's go.
Can we flip over?
Okay. Go on.
Yep, okay. Am I going to see it up here? Okay, great. So I don't know if you can see this, how clear this is going to come through. So if I go cats, does that come through at all?
The angle is, the thing is at an angle.
What if I move it over here? Did we lose it?
You have to make it a little bit higher and then
higher?
you can do it.
Sorry, everybody. Technical difficulties.
Yeah.
All right, okay, hold on.
It's okay. Yeah, stay. No, it's okay.
Is it good now?
Yeah.
Beautiful. Okay. All right. So let's do not this one. Let's get that one. Generate. Are we going? Okay. So anyway, we're probably lagging behind, so I'll just do commentary in this. So what you're probably seeing here is the mediated types config file. So what is going on here is this is actually just a text file that's explaining to the kernel precisely how the mediated types are laid out. So this is like just the number of the device, that's an identifier. The max instances, frame buffer length, that's your VRAM. This is frame buffer reserve, hypervisor reserve memory. That's the name of the device that's presented into the guest and on the host. The GPU class is kind of an internal identifier for the GPU, depending on the GPU driver. The VDEV ID is vendor ID, and then device ID. In this case, I think we're presenting in something that's like a P6000 or something, even though it's not a P6000. So the number of heads, the displays, the max resolution, the frame rate limiter, if it's enabled, if it's not, if ECC is on, and then right below that is, I'll try to bring it down slightly, mappable video size, and bar 1 length, which may or may not come up in a half second. Okay, anyway, so what I'll do next is I'll just show you what you can do here. So we go and we can apply this. So we'll go and are we actually looking at the bottom of the command line or no?
Can you try scrolling out?
I don't know. It's lagging so far behind. I actually don't know if it's going to even get shown. I could try reducing the size of the window maybe. So I'll go mdev CLI.
Yeah, try reducing the window size.
Yeah, I believe you are.
Yeah,
right now
it's okay. Yeah.
Okay, great. Okay, so then I should be able to do etc mdev. I have to do C. Let's go etc gvm mdev GPU generate vGPU types. So what I'm doing here is I'm applying mediated device profile. So this is effectively going into the kernel and it's registering mediated devices with the mediated core. So basically it's telling them that there's vGPUs available. I'm freeing memory resources, sending in things to the kernel, telling it how to configure the device and the driver. So if we were to go list mediated types now, you can see when it eventually comes up that all these types are now listed as available mediated types. Yeah, so there they are. They're actually registered with the kernel now, so we can use them. So normally this stuff, if you wanted to use this on a consumer grade GPU, well, first off, it wouldn't work. There have been things like vGPU unlock, which can kind of enable it, but all these values, all the way that this is laid out, is all hard-coded, and there's signatures that block you from making any kind of change on this. And that's largely just anti-user limitations, because this is all written GPL v2. You can configure it yourself. You can do pretty well whatever you want with it. So let's actually do a live demo of what it looks like when you're running something with this. So I might have to move this out slightly so you can see it a bit better.
It's okay.
It's good? Okay. Yeah, so this is a vGPU VM coming up. What we're doing with this is we're using something called Looking Glass, which is effectively a shared memory device between host and guest.
You might want to change your laptop so that its display is vertical instead of tilted.
Do you mean like moving it like this?
No, like so that the display instead of being like
the screen from.
And so that instead of the screen being like this, it's straight up and down.
I gotcha. Okay.
And now you have to move the camera
this way?
to the right.
Yeah. Okay, sorry for all this magic. Okay.
Rotate it so that it's like straight.
All right, I'm doing my best here. Hopefully we get there. Okay, so when it eventually comes, and I'm hoping it will in a second, what you can kind of see here is this is obviously just a Windows desktop. If we go into the NVIDIA control panel, when we eventually get that to come up, we can see that this is actually GVM mediated device. There we go. So what I can do is I can pull up a graphical application, run this. This is just like the Unigen Heaven benchmark. You might have seen it before. It's pretty common. People will use it whenever they're just running a GPU. I think I have vsync enabled on this, so it should just go to like 60. But if you pull, yeah, there we go. So if you pull vsync off, it runs at like 200 frames a second. So basically there's no, it's not really coming through here, but like I'll hold it up so you can kind of see. This is just solid 60 pretty much. Yeah. So we can actually run a couple VMs at a time, but I'm kind of pressed on time, so maybe if you guys want to talk to me afterwards, we'll go through and do a little bit more. So I'll just hop out of this and go back to the slides. Okay.
Okay. So right now we have slides.
Yeah, okay. Michael, did you want to come to the IO resource management? Do you want me to do the clicker, or do you want to do it? There you go.
Okay. So,
this is Michael, our CTO.
Hello. The plugin system requires a certain presenter. We need to create a virtual display, otherwise Excel NVIDIA card doesn't recognize it as an HDMI connection inside the VM. So,
It takes about 10 seconds to go forward.
I've been trying to go back to a slide.
Now you are. The display in front of you is...
Oh, okay, perfect. So when it comes up, there's 3 different types of resource management systems that we can use. We can use a hardware-based approach, we can use a user space-based approach, or kernel/hypervisor-based approach. So in the hypervisor-based, hardware-based approach, we get speed performance, we get security enforced by a hardware construct, And it is much easier to implement from the term of a consumer developer. The developer doesn't have to worry about the scheduling of the system or certain mechanisms such as how a MMU works. Now, there are certain cons associated with it as well. Which our silicon level flaws are typically unpatchable. It's still a black box in a lot of these situations. But the biggest flaw is that we have this abstraction layer which allows for NVIDIA, AMD, Intel all to generate their own mechanisms by which to do it, creating more and more vendor-specific code. When we had AMD versus Intel, we have two different virtualization technologies on CPUs, which are much more complicated to interact and certain bugs on each individual system. It's also expensive to fix an older system, so you can't just open it up and replace a single component because they are in the nanometers. Now, in the user space management, we have the capability to use user space abstractions. We can use callbacks. It's easy to solve the exploits, more so in the fact that if there's an exploit here, we can patch it either in the kernel or hypervisor, or we can patch it in the actual user space once we actually can. Much easier to test because a segfault in user space doesn't destroy the system and make it unbootable. Exploits are not as dangerous, and it allows you to isolate the code. Inside the user space, however, it's much slower. The reason is because we have a VM exit, a kernel entry, a kernel exit to a user space program, then we have another kernel entry, and then we have finally the VM entry again. And it also is quite dependent on the tool chains, as we've found out ourselves. Dynamically linked libraries are required, and it's also easier to build and distribute malware in the form of these plugins. We have kernel space or hypervisor space solutions later on, which are going to be faster than the user space. Unfortunately, they'll be slower than hardware, highly optimized. And this component has to be built either way for the actual interaction with the QEMU process or whatever process handles the VM itself. Now, there are certain flaws with kernel space as well. It's incredibly hard to test. A segfault typically requires you go and restart the machine. Exploits are quite harmful.
Trust me, I've learned that.
Okay, we're alive.
Oh, perfect. Exactly what I said. So, on the roadmap we have... Oh, yeah.
Okay, I'll blast through because I know we're nearly done. Okay. Give a round of applause for Michael. All right, okay. So roadmap, because people have been pointing out to us, this thing here is something we suck at really, really bad, which is packaging. We have 0 packages. Everything is like basically built from source. Got to fix that. People are angry. The GVM API for runtime redefinition, supporting basically just changing the VGP types at runtime, looking at that. We want to have a community sort of request for comment system, so we really want the ability for people to give us input on major API changes and design proposals, rather than us kind of just building a bunch of things and then hoping people in separate software ecosystems will adopt it. Rather, we want people to be able to give input. We want to also support different and new sort of driver backends, new sort of device microarchitectures. We don't want to necessarily be on any particular vendor. We want to support everything. We also want to get into advanced GPU virtualization techniques like shadow page deduplication, basically having the memory of a particular virtual machine. If we have like 20 of the same VM with all the same assets, we want the shadow pages to point to the same addresses. We want to do object import-export between VMs. We want base address register resize so that obviously we can change the size of virtual machines at runtime. Very quickly, use cases for GVM, gaming, and did I skip right past it? I did. Gaming and GPU acceleration for Windows. Gaming and GPU accelerated app acceleration for Windows programs. A lot of people like to play video games on Linux this way. Most of the people in our community are using it for that purpose. Another thing is we could potentially use this for like load balancing of GPU applications. Turns out many applications with GPUs kind of get treated, like the GPU almost gets treated like a Commodore 64 in that you kind of just send it an application. It doesn't really know how to properly balance resources normally. In the context of this IO virtual address translation stuff, you really do get very strong, effectively quality of service stuff where it can limit the scheduling time of a particular task, kind of server related stuff. People would use it for VMs. So obviously bringing it to the desktop and having that kind of quality of service stuff would be helpful. Security by compartmentalization, obviously the stuff that you guys are interested in. We think that you could do things like, for example, if you have an automotive manufacturer running secured CAD, that kind of thing, they have a CAD model, maybe at the same time they want to have email, they want to have the ability to view PDFs. With current virtualization of the GPU, I don't know how good it is. No, I would probably speculate that this is a little bit of an improvement over the existing methodology. If that were the case, maybe it would be good to adopt something like this in Qubes so that people can run performant GPU accelerated applications and obviously benefit from that. Okay, so final slides. Come join our community. We would love to have more people give us input on how to design these things, how to do them better. All of our documentation is 100% open. The signups are literally, you can go onto our OpenMDev, sign up for the thing. You can contribute whatever you want. You can read it. It's all open. We're not hiding anything. Send us issues and pull requests on GitHub. The repository is under OpenMDev. GVM user is the current repository you should check out. All of our documentation is at docs.linux-gvm.org. We have diagrams, we have import graphs, we have side effects, we have restrictions, we have anything else that I missed?
That should be it.
Yeah, I know I'm running over time. I'll wrap it up in a second. Failures, yeah. We have monthly community calls, first Wednesday of every month. Really fast areas of potential collaboration for our hackathon. We might want to look into doing something around IOMMU groups because the support for that isn't really there. It's kind of a unifying thing between the VFIO ecosystem in KVM. Might want to look at the thing I was showing earlier with the very fast graphics being displayed on the host by a shared memory. That's something called Looking Glass. The memory sharing primitive in that under the Looking Glass memory protocol is currently IVSHMM, but I just talked to the guy who created it. Looks like it should be possible to port to grant tables, but he might need some help from people who know more about Zen, so maybe we could talk to him about that. And possibly other methods of directly acquiring guest frames without having a shared memory device. So, directly inspecting the memory, we might be able to do that from the host, or potentially something around using an indirect display driver, which is kind of like a Windows API. Yeah, okay, we're done. We're getting told we're done. Anyway, thank you so much for listening to us. Thank you so much for letting me have time. Can I take like 3? Okay, go for it.
So question from Zil Brother from the community. Did you try it SRIOV on Intel Xe IGP?
Yes.
Yes. And it works?
It does work. It works well, but the problem is you have to compile a kernel for it because they're trying to upstream the code right now, and I won't speak for them because they're some level of confidence between us, but they are working on it. It does work if you compile their kernel.
I was told on the DRI Devel IRC that the reason it is not currently accepted upstream is because apparently the code quality is very bad.
We have NDAs. We know what's going on, but we can't talk about it.
Yeah, we don't like to do NDAs, but we can't talk about it. Yeah. Anyway, any other questions? No other questions?
Yeah. So for Looking Glass, that uses shared memory. Would it be possible to instead use GPU side shared memory so that, for instance, on the host it appeared as DMA buffs?
You bet it is. In fact, there's people that might be at another vendor that are maybe doing exactly that thing.
Okay, because that would be awesome, especially with Wayland, because with Wayland you can just import DMA buffs into it. And also, the other thing is, have you considered the parts that deal with untrusted input?
Mm-hmm.
having your control plane, the stuff that only deals with trusted data in C isn't really that big of a deal. Qubes is libvirt is in C, for instance.
Yeah.
But having the same with like Excel, but like the stuff that deals with untrusted data, that I feel would be much better in Rust.
Won't work. So actually, before we did it in Haskell, we did it in Rust as well.
Yeah.
So we did Rust to Haskell to C. So yes, Rust just doesn't work mostly because of the fact that we are still kind of having to do a bit of reverse engineering to actually solve this problem. And part of that is we need to know the memory offsets of each field in a C structure, for example.
That can be done. I
know it can. It is a nightmare. I have attempted to.
We'll discuss this later.
Absolutely.
This sounds like
later.
Yeah. The only other thing I was going to say is the one other advantage of getting rid of the inter-VM shared memory device is we don't have to install a driver in the guest. We can just grab the memory directly on the host. No additional changes in the guest need to be made. So I think that would be the best long-term solution.
Yeah, we have graphic subsystem design discussion, and this would be definitely a good topic.
Yeah.
And so maybe other way, because it's like a lot of stuff is for me complex. But how in simple words we can say about, because you're saying about security, but what it really gives to end user, in terms of end users of secure drop, or in terms of what Marta said in, human language, not hackers language.
Yeah. So I think the best way to put it is that it gives you very close to native GPU performance and accessibility of all the APIs that most video games actually use. Like, turns out almost every video game uses
unleashing
DirectX.
the power of GPU that you already bought.
That's right.
Paid for.
It turns out all the things that are like the special sauce server stuff actually work in every GPU. The GPUs you already own actually can do it. It's just the magic. We're starting to put it out, make it available to people.
And from security perspective, what's really possible if you use that?
Well, one of the things that's the most immediate advantage is just like the ability to actually enforce IO virtual address separation for guests. So rather than just kind of treating it as like one requester, having it all be in one big shadow page, and maybe you're doing something with software to separate it, it's actually using the GPU GMMU controller in order to separate out IO virtual addresses for each of the guests. So every time a guest wants to perform a memory translation with its memory, it's going through an MMU controller for both the MMIO window in RAM and also the shadow pages for the GPU in the GMMU controller. Yeah. So it's not like remote FX where they deprecated that thing because it had you're basically the hypervisor asking politely, hey, please don't run your address space. This is the hardware actually enforcing the separation.
Okay.
Yeah.
Partially I understand, but to be honest, it's
we can dig into it more if you want.
Sure.
Okay. I've probably generously used maybe 20 minutes more than my allotted time, right?
Not 20, but 8.
Hey.
Thank you for your presentation.
Thank you.
Well, yeah. I think you need the slider. Yes. Yeah. Hi, I'm Buck. I'm going to talk to you about Wayland and why it rules and why it should be used more. Start off, I am working with. Oh, did I accidentally unplug it? I think that may have happened.
Oh, yeah. Oh, that's right. Now we should be able to. Okay. So let's start from the beginning. Are you able to?
Yeah, now it works. Okay. So I'm. Now it doesn't work. Whatever. So I'm working on a project called Spectrum, which is a compartmentalized OS, somewhat like Qubes, but with a few other design goals. Like it's based around NixOS, Nix packages and NixOS style mechanisms. Is this?
Let me try. Sorry for that. Check if it's connected, please.
It seems to be connected, but...
Yeah.
Oh, oops. Try it. Yeah, there we go.
Yeah, now it's working.
Alright, so I'm working on Spectrum together with Alyssa, who is also here. And it's more of a, I believe it's more of a research operating system than Qubes is. A lot of it is not yet finished, but we're working on a lot of cool stuff. So, first some history about Windows servers, because that's always fun to start with. In 1984, they released X1. MIT released X1. In 1987, we got to X version 11. And in 2022, we are still stuck with X version 11. And you can imagine that in 1984 and 1987, the world of computers looked a lot more different. We had high latencies, low speeds, and most of all, not a lot of memory. So the Windows servers X was designed for that kind of situation, which meant that when you look at, for example, a browser of the time, it looked like this. It's about that speed also. And the X server, which took up a lot of the job of rendering stuff. Buttons, for example, were done. Buttons and fonts and everything was all done by the X server. But in the modern days, we have a slightly more advanced graphics than this, and browsers quickly look like this. Lots of large buffers and lots of large buffers, high resolution, high speed, and getting that all in one protocol is ends up with a lot of historical craft. For example, there's no ACLs. Every every client can do whatever it wants. They can read your keyboard inputs, take over your mouse, draw window borders, etc. So you don't want to use this for if you want to build a secure operating system, because you don't want your PDF client to suddenly be pwned and you end up with a PDF that takes over your mouse and reads your bank information. So, current state in Qubes OS is that there is a custom protocol which runs an X11 server per amp VM. That is a lot of legacy code. And to make to render this, every window is rendered into a shared memory buffer, and the shared memory buffer is sent over a using a method called Zengrams, or like in the previous talk, the equivalent to the shared memory IVH SHM thing. And this means that every app VM runs its own window manager effectively. This is good because it means that there's not a lot of security that you're actually leaving to the X server, because that thing is a lot of code in C. But there's some disadvantages, because you end up with a lot of missed opportunities for graphical integrations and stuff. So, in 2008, a newcomer appeared on the block, Wayland. And Wayland has had 20 years of hindsight in computers, and even in 2008, we already had fancy browsers and graphics. So, Wayland uses a way simpler protocol than X because it doesn't need to do fonts or buttons. All it knows is Windows, basically. There are some disadvantages. It's not network transparent. So you do have to deal with, because it uses shared memory everywhere where possible, because that's just way faster than trying to push hundreds of megabytes over a network connection. But it is more isolated by default, where every X window could do whatever it wants. In Wayland, you don't get to do anything, basically. You don't even get to know where your window is on screen, or if it is on screen even. And the biggest advantage, in my opinion, is that Wayland does not have one implementation. Because the protocol is so simple that you don't need to depend on the X server to implement it. You just implement it for every window manager again. And that also means that there's implementations that aren't in C. For example, Smith A, which has, I believe, been mentioned before already, which can be written in completely safe Rust. It's amazing. And obviously, X is dead. There's basically no updates to X anymore except for X Wayland. So, we can take this and just pass it through to a VM, right? Well, we need a little bit more work for that. Namely,
this thing is slow. It's not. I'm not.
No, I was looking at this thing, but Virtual GPU, the worst named Virtual device in a while, I think, because it is not just for graphics. You can also do. One second. I'm gonna quickly. You can also do Wayland over Virtual GPU these days, using something called the cross-domain context type. Oh my God. Yeah. Nerves. Have it on the presentation.
X11 is the reason.
Big X11 trying to stop my presentation.
Is the remote working right now?
Yeah. So, Virtual GPU, other than using 3D acceleration and 2D acceleration, recently, of all companies, Google has upstreamed support for Wayland into Virtual GPU using something called the cross-domain context type. Why Virtual GPU and not something like Virtual Wayland? No idea. But the mechanism was already there because Virtual GPU is also revealing Vulkan passed through using VNets. And there's another advantage to this because, right now I'll be in bed. Oh, why does my throat have to? Sorry about that. So, to get Vertera GPU Wayland working, you do need a bit of custom work because most Wayland clients will not know how to talk to a GPU for Wayland. So, some clients like the current VM proxy that current X11 proxy that exists in every VM. There will have to be a Wayland proxy, but that one will be way lighter. And its job is very simple. Take the commands that come in over a normal Wayland socket, send them through the VM barrier to the host, and add a lot more logic to, but there's obviously also the things with window where you don't want to give full Wayland access because you will be able to spoof any window you want. So there's a mechanism that is in the works that I'm working on and that Immersion has also been doing some stuff on, and it's called security context. Security context allow you to create more Wayland servers effectively. Each Wayland server will be tagged with a sandbox engine and an app ID. For example, you could say the sandboxing engine is Qubes and the app ID is the name of the VM. And this allows you to then, in the compositor, do policies like this window will be allowed to do certain things, this client. Or, for example, you can do colored window borders with Wayland. And in fact, I have done so. On the left, you will see a Firefox window that is running inside of a patched version of CrossVM, which is the hypervisor that Google uses for their for Chrome OS. Yeah. And on the right, you will see Flatpak, not containerized, but running an arbitrary program that I chose because it is small. And you can see it's also tagged with, currently I just put, in this demo I just put the app ID in the title because it's simple, it works. But you could, obviously, if you have a compositor and you want to spend more time changing it, you could make it do, for example, full colored window borders. You could say, have other policies. But there's more stuff that you can do once you have Wayland and Vertera GPU and stuff, because Vertera GPU is not just for Wayland. You can also do 3D acceleration through it. With, for example, Virgil as mentioned, or you could probably even get this working with mediated device GPU as mentioned before by using the object import export that is on the horizon on the and obviously Wayland has way more integration. Sorry, yeah. Once you have Wayland stuff, you end up with this, compared to the current setup that Qubes uses, where you have a relatively, a very, very restricted subset of events that can happen. Once you have Wayland, because Wayland is designed for this kind of isolation, you already have a lot of more support from existing software that integrates with this. For example, if you've used Flatpak before, you may notice that open save dialogues just work as usual, because and they show up as part of the window that you're opening and saving from, even though those open save dialogues are relatively privileged. That's because those use a mechanism called XEG desktop portals, which surprisingly haven't actually been mentioned in UX things yet. But it's a mechanism that allows you to do super cool tricks like have open save dialogues. If you've tried to do screen sharing on Wayland, you've seen screen share request dialogues. Basically any kind of privileged pop-up that the system that may need passing through into a container or virtualization or sandboxing engine of any sorts will usually go through an XEG portal on current Linux desktops. And for example, I can imagine that in PipeWire talk that will be after this may also be mentioned. I don't know. But the cool part about this is that if you're using Wayland pass into a VM, this mechanism all just works. And it's one of the things that I want to look into, at least for Spectrum, and possibly this research can all be reused for Qubes OS as well, obviously. In my opinion, the future of Qubes and Spectrum and all these kinds of compartmentalized operating systems and secure operating systems, I think it looks pretty cool so far. I went through this a lot faster than I thought I would go.
No problem.
Yeah, that's basically all I've got prepared.
Do you see a way where potentially an alternative sort of GPU thing other than maybe VirtIO GPU could be used?
I suspect at this point that VirtIO GPU will probably be reused for now.
Yeah.
The original design that Google used also was using something called VirtIO Wayland, but I believe they stopped doing that because it's really expensive to get a VirtIO device registered with as an official specification. And Wayland and graphics are kind of inherently bound together.
Right, that makes sense.
And currently, using Virtual and Venus is kind of the standard for GPU acceleration through virtual machines combined with Wayland. And that is, for example, what Google, if you use Chrome OS these days and you run a Linux VM, that is also what you get.
Yeah.
You get a full VM, you get full graphics. Prior virtualized graphics effectively.
Yeah.
And I was thinking during the MDev talk, during the VGM talk, that you could totally use the object import export stuff to do the same kind of trickery with Wayland and get highly accelerated graphics through there. But I was also thinking that it was going to be a bit of a pain because VirtIO GPU DMA bus versus other DMA bus.
The one thing I was just going to say was that, at least in the context of everything that's default QEMU, yeah, totally, it's definitely the default that people are using VirtIO GPU, that kind of thing. But when you go and you read the Red Hat docs, it's virtualizing a GPU, just go pay for this thing, and it's this, basically none of the open source really uses it except for when you get into reading how do you set up a Red Hat server with GPU virtualization.
Yeah, the other thing is that there's currently, I believe, only one implementation of VirtIO GPU that supports Wayland, and it's part of CrossVM. I believe Alyssa has successfully gotten this to work with Cloud Hypervisor just a few days ago.
Yeah, that's interesting, Cloud Hypervisor.
but still using the cross-VM's Virtual GPU implementation of a VOS user.
I won't take up any more time like talking, but I suspect we're going to have great conversations after this.
Yeah, don't worry. I've had too short of a talk so far, so.
Yeah.
So, I guess the question. The first thing is, would it be better from a security/attack surface isolation perspective to use one of the more hardware-isolated vGPU approaches compared to Virgil or Venus?
I kind of consider both to be similarly on a similar level regarding security, because both of them kind of have to deal with a relatively large software stack and a surprisingly large amount of hardware. The advantage of virtual GPU stuff like Virgil and Venus is that your attack surface is similar to that of two normal applications running and accessing each other's GPU memory.
I'm thinking more along the lines of, for instance, because if I understand how Virgil and Venus work, they both basically send some sort of IR to the host.
It's basically serialized command streams that you would use for Vulkan and OpenGL.
Yeah, and so what I'm thinking is that I'm imagining there's a rather large attack surface in terms of the host, like where there could be a memory corruption bug in the host's OpenGL or Vulkan implementation. And so what I was thinking is that especially with SRIOV mode on like Intel GPUs, there's a lot less, the attack surface that is, the software attack surface that is exposed to untrusted input, because the stuff that is not exposed to untrusted input doesn't count. The stuff that is exposed to untrusted input seems to be a lot smaller.
Kind of, yeah. I would say SRIOV is a pretty good solution to this, but mediated devices and like OpenGL and Vulkan command serialization are like both deal with relatively like hardware that isn't quite designed for isolation and trying to make it work isolated. Yes, I do know that a bunch of the mediated device stuff is hardware backed, but I don't trust it.
So the other thing I was going to say about that was that they added it in the GFMU controller in Kepler precisely for IO virtual address translation. So like the idea being that like guests, when they do some kind of memory operation, can't run their address space, and it technically isn't executing on the host. It's just like a context swap between.
Right. That's a lot more reasonable. Yeah.
Yeah.
Do you mind if I add something? So something that's maybe important to clarify is that Virtual GPU is not tied to Virgil or Venus. At its core, it's just a mechanism for doing shared memory between guest and host. So the Wayland stuff is completely independent of Virgil and Venus, and can just be used for transporting the Wayland protocol of shared memory buffers of all sorts between guest and host. So you could do it even with a GPU passed through to the VM and render on it. You'd have to copy out because it would be all passed through. And oh God, what else was I going to say? Yeah, so Virtual GPU is sort of fast becoming the standard way to do KVM shared memory as well. I was part of a conversation a few days ago that proposed making shared files with VirtualFS also just reuse Virtual GPU rather than adding their own thing. So coming back to your question about would it be possible to use a different mechanism, I think it's more likely that Virtual GPU is just going to become the standard way for doing all kinds of shared memory. Because, for example, a lot of the more modern VMMs like Cloud Hypervisor and CrossVM and so on don't have IVSHM. And Virtual GPU seems to be shaping up to be the new way of doing that.
I'd like to eventually have. I don't want to cut into your time. We'll talk later.
Yeah, I guess I'm just thinking from a security perspective. I'm just thinking more in terms like Virtual GPU. I'm guessing is fine. It's the Virgil and Venus that worry me.
But we don't have to use those.
To be fair, Virtual GPU context types are like relatively recent, all things considered. Like for a long time, Virtual GPU was just Virgil and nothing else. Or well, 2D acceleration as well. and then at some point Venus appeared and Wayland appeared, and those just ended up being slotted into Virtual GPU because that's the easiest way to make them work, basically.
In the context of Virtual GPU, I'd like the mediated device stuff to basically just be Virtual GPU. That would ideally be the best scenario because then it would just support everything.
Yeah. Another great discussion for graphics subsystem design session.
Yeah.
So that's pretty much all. Thank you for your presentation.
Thank you.
Demi Obenour from Invisible Things Lab, and I'm here to talk about evolving Qubes OS's audio-visual stack. So, outline of the talk. First, I'm going to be talking about audio, then about video capture, and then about moving from X11 to Wayland, which is heavily going to overlap with what Puck just talked about, but not quite the same. So the current stack is that Pulse for audio is that Pulse Audio is used as the audio server. In the audio VM, there's Packet Simple vChan, which is the audio, which is basically the audio daemon, and there's a custom Pulse Audio module in the VM that is audio services are provided to, and that's responsible for transmitting audio signals between VMs. Packet Simple vChan is, as the daemon is the privileged part, it's responsible for access control. Playback's always allowed, but by default recording is blocked. You enable recording by attaching the magic DOM0:mic device, at least assuming that the audio VM is DOM0. I haven't seen what happens otherwise. Marek, do you know?
I'm not sure what really happens. Probably it's broken.
Okay. Okay. Yeah. The problems, well, there's some obvious and not so obvious ones. The obvious ones are that there's a poor recording requests aren't handled well. If recording is blocked, and then all you get is just a log message in a text file that nobody reads, unless you're debugging. And furthermore, the queue appears to have a broken microphone, meaning that it appears that it seems like the microphone is there, but but any application that tries to record never gets any samples. So some applications will see that it's not getting any samples, they'll stop using it, and even if you then allow recording so it would start getting samples, they still won't use it. Looks at Discord in particular. So anyway, it seems like WebRTC, but also I think other WebRTC things seem to have this problem. And the user experience is bad. It works when used properly. Well, yes, it does work when used properly, but that's not enough. People will make mistakes. I make those mistakes. Like, for instance, they'll join a call, but they'll forget to attach their microphone. Like, there have been so many times when I've had to be reminded, we can't hear you. It's like almost become like a meme or something that Demi's got something complex, and so her audio sometimes doesn't work. Not sure if anyone else here has had similar experiences.
We did, yeah. Many times.
Always.
Once a day.
Yeah, Piotr's using this Qubes OS thing, that's why we can't hear him.
Yeah, and that also kind of gives us a not so good rep. Less obvious problems. Latency is very noticeable in a simple echo test. I have been told that test that I did was not very well designed. So I don't know if that's actually an issue with Qubes or with my tests, but still. Pulse Audio is incapable of ultra low latency, as in like professional audio kind of stuff, or like what you need for like music software. Pulse Audio is not very actively maintained. The person who created it, Leonard Pottering, went on to System D. You can't safely expose the Pulse Audio socket to sandboxes, which is annoying in the world of Flatpaks. And if you want to, probably from a maintainer perspective, the most annoying part is that if you want to write a custom audio sync or a custum source, you have to use the Pulse Core API. That's not stable, so distros don't ship development headers. And as a result, our Git repository is like Pulse Core headers for like tons of different Pulse Audio versions. And while the while it's actually required changes only a few different times, it's still annoying for people in rapidly evolving distros. Looks at Arch. Also, the frame rate, the sample rate isn't great. 44,100 samples per second was fine in the past. By the way, if I'm talking too loud or too fast, I mean, please let me know, because in case one of you can't understand me. 44,100 samples per second was fine in the past. Nowadays, most things use 48,000 samples per second. And this requires conversion, which adds latency and uses a small amount of CPU. So what is PipeWire? Well, it's created and maintained by Wayland, who's one of the creators of GStreamer. It's designed for low latency in a virtualized environment that might well require scheduler tuning, not tested. It supports both audio and video, and it supports existing applications, whether those be using GStreamer, Pulse Audio, Jack, or ALSA. It creates an extensible plus processing graph that applications and plugins can add to, which is really nice. And the API for doing so is stable. It supports both standard and professional audio. It supports video, including both V4L2 and libcamera, which means it's an alternative to the out-of-tree V4L2 loopback kernel module. It's got much lower latency than Pulse Audio. I haven't measured it, but I'm going by the fact that Jack is a thing, and otherwise it wouldn't really need to be. The module API, and even from what I can tell, ABI, is stable, which is nice. And it's designed to be safe to be exposed to sandboxes. Obviously, anyway. Integrating into Qubes, well, Packet Simple vChan works with no modifications via the compatibility layer. I may switch to a native PipeWire implementation someday, but that can come later. Initially, the initial pure PipeWire version will still run out of as a separate process. If it becomes necessary, it could even be loaded into the PipeWire daemon itself. Obviously, the Pulse Audio module that used the Pulse Core API had to be rewritten. I used the sample source and sync as a basis for that. It's written in C because while there are Rust bindings, they don't support writing modules. And the API is one of those annoying ones where you get a callback when X is about to be destroyed, and after you returned, any pointers you have to X are now dangling, which is less than great from a Rust perspective. But still, I guess the bigger thing is it would likely be more work to write Rust bindings than it was to just do it in C, with one somewhat major caveat, and that is threading. In PipeWire, you've got the main thread and you've got a real-time audio thread. And the real-time audio thread is where you want to do your actual audio processing, so libvchan read, libvchan write on the vchan. But creating and destroying vchans can't be done there because they're not real-time safe. So because of that, and also vchans cannot be concurrently used by more than one thread at a time, and there's some control messages that have to be done on a vchan. So you wind up having to bounce back and forth between bounce ownership of the vchans back and forth, and it took me a while to fix all the seg faults as the daemon was shutting down. Also, one thing that would really help would be a libvchan reconnect function that was real-time safe and non-blocking, that would avoid having to pass the vchan to the main thread to destroy it, and for the main thread to create a new one. So now onto video capture. The current situation is bad. It sucks. For USB cameras, there's USB pass-through. It's not secure. Video receipt. The obvious attack surface is as it sounds. It's not reliable. It often disconnects in the middle of a call. Yeah, that's a bug. it's might be a bug in how the kernel's USB IP stack or something like that. I don't know where it is. It'll have to be dealt with in any way. But anyway, it still impacts people. Everything else, no support. And no, write your own QR exec service doesn't count. Maybe some of the people in this room could do it, but the average person certainly won't be able to, as Marta pointed out. Elliot Killick, who unfortunately is not here, at least from what I can tell, came up with a solution, Qubes Video Companion. It supports cameras via v4L2, it supports screen sharing currently via X11, but it's based on GStreamer, so it's going to be very easy to extend to support, say, lip camera or PipeWire. And PipeWire is important as a video source because that's how pretty much all video works under, let's have, for instance, screen sharing works under Wayland. Excuse me, dang it. I mean, it's actually funny because when the GUI, there's more, I'll talk about this more in the Wayland section, but anyway, screen sharing on Wayland turns out to be quite complicated. Currently, the data flow is strictly unidirectional, as in at least as far as QR exec is concerned. I mean, there's obviously bidirectional data flow for flow control and the like, but from QR, outside of QR exec itself, the source just sends raw video frames over the pipe. And that means that the attack surface on the destination is very low. It didn't make it into R4.1. I hope to backport it, assuming I get the okay. It will be included in R4.2, hopefully. The things that are still left to do, sample rate and resolution need to be adjustable. That could either be manual via a drop-down, or it could be automatic. And the reason for that is that we don't have hardware. Well, there's a few reasons for that. One of the big ones is that we don't have hardware video encoding acceleration. That's something I'd like to add because it seems a lot less problematic than video decode acceleration, and also because encoding is a lot more compute intensive than decoding is. But anyway, most systems cannot do real-time software video encoding at high resolutions at frame rates. It winds up consuming a whole CPU and still being very laggy. So that needs to be adjustable. Also, I'd like to drop the dependency on v4L2 loopback because it's an out-of-free kernel module, and those are not great. It's not likely to be upstream soon because the kernel developers don't like the idea. I think it's because they want to keep people from using it to write user space camera drivers, which I get why they're doing that. Unfortunately, it seems like that's a lost cause because of how complex modern image processing units are. But PipeWire is the logical replacement, and most things hopefully support XGG desktop portals via PipeWire, and in that case, with this providing a video source to PipeWire, it should just work. And so the next thing is graphics. From X11 to Wayland, because as Puck mentioned earlier, X11 sucks. It's got problems. Those problems won't be fixed. Just to give you a few examples, we get lots of bug reports. Like, for instance, the user clicks window X and the VM interprets it as a click in window Y, or the user drags some data and drops it on a window, say owned by a different cube or not owned by anyone, and that should just do nothing because we deliberately don't support cross VM drag and drop. But it winds up getting dropped on a totally different window, which can even be a security issue if, say, data gets dropped by accident into a shell. Yes, that's happened to me on more than one occasion. It's the single main most common reason I've had to use QVM volume revert. LibreOffice opens in a tiny window by default. Firefox will freeze eventually. Cause for that is unknown. There's no support for touch screens. That at least could be fixed, but there's the question of is it worth the effort to do so? And the solution to these problems is often really unclear. The various protocols for inter-client communication under X11 are horribly documented. There's nasty race conditions which are almost impossible to fix because there's a lot of client-to-client communication that doesn't go via the X server, and it's also really hard to just even get events to the right place. Like if the user clicks on window X and then it's injected as an event via the input driver, this X11 virtual input driver, but then the VM's X server does its own event routing, and who's to say that it is always going to agree on what the window should get the event? And it turns out it sometimes doesn't, and it's very hard to prevent that. Drag and drop doesn't work reliably because the cube doesn't know if the cube does not know the global stacking order, and that's really annoying. So drag and drop can't work reliably because it doesn't know what window should be dropped on, if any. And of course there's the elephant in the room, which is override redirect windows. They've been a security problem since before Qubes 1.0. There's mitigations against them, but they can almost be bypassed. The only thing that can't be bypassed is that little 2-pixel color border. And there have been past QSBs that allowed that to be bypassed too. And it's, of course, really hard to deal with this without breaking things. Because, again, X11 assumes that everything has knowledge of everything, and it's really hard to break that assumption. Wayland, everything is a lot nicer. You've got a compositor. That's the only thing you've got. The compositor is the GUI agent, so you don't have to worry about a lot of the stuff you have to deal with. There's nothing, for instance, the compositor just does its own event routing. Copy and paste and drag and drop are the only things that natively involve inter-client communication, and even that's mediated by the compositor. It's a much simpler protocol than X11. It's much better documented. There's a huge number of race conditions simply don't exist. And as Puck mentioned earlier, applications simply don't have access to any global information. So they can't make assumptions about it. So therefore, under Wayland, applications are a lot less likely to break than they are under Qubes. Because, well, they aren't going to make broken assumptions that are under Qubes are broken. So, as Marek pointed out earlier, I initially tried Smith8, but that ran into problems. Smith8 at the time did not have a scene graph, damage tracking, or a software render, and I am told now that it does. There were also concerns about its dependency footprint, which is rather large. It's so I wound up switching to WL roots, which is used by Sway, River. Parts of it, though not the parts Qubes uses, I think, are used, or Qubes is going to use, are also used by KWinFT. So it's all in all, it's considered a very high quality, very widely used toolkit for writing compositors. It's mostly written in C, unfortunately, because there were no maintained Rust bindings at the time. But the GUI protocol implementation is itself mostly in Rust, and I'm planning on moving the rest of the protocol implementation to Rust as well. If there's, once WL roots Rust bindings get ready, I may switch to that, or I may at some point, if Smith8 gets to a point where it can be used, may use that as well. At some point, who knows? The status of it, well, it's pretty good, what I've got so far. Terminal emulators, the ones I've tested are GNOME Terminal and Foot, those work. And it's good enough that when working on the compositor, I use GNOME Terminal running under that compositor, because I use Vim as the editor. So it's in a sense, it's bootstrapped. Copy and paste works, that includes the Qubes global clipboard. Drag and drop doesn't work, because I'm not going to do a bad implementation. If I implement this, it's going to be implemented right, and that means that I need to ask the GUI daemon, where do I drop this data? Tray icons aren't yet supported. That requires a status notifier item implementation. Hopefully that can be shared with Spectrum. Wayland is not yet implemented, but it shouldn't be too difficult. That I may use the proxy that Spectrum's also looks like they'll be using, or I may use WL Roots' native Wayland support. Not sure which. Which brings us to the other thing, which is the GUI VM side. That's a significantly harder task than agent development, mostly because the current GUI protocol exposes things like absolute window positions, which aren't available under Wayland. So the protocol so either those things will have to be emulated with, for instance, fake window positions, or the protocol itself will have to be adapted to not rely on them. The first step will be to run the GUI daemon with the existing protocol under Wayland. That may already work, have it tried. In any case, for compatibility with Windows and X11 agents, there will need to be heuristics. Ugh. The good news is that the Wayland daemon, which is what I hope to write someday, which will be written in Rust, and it'll be a completely unprivileged Wayland client. And as far as whether there'll be a Wayland daemon, or if Wayland will just become the GUI protocol, that's going to be up to most likely going to be up to Marek. I'm mostly fine with either. My current intuition is that attack surface-wise, the attack surface of Wayland itself, limited to only a small subset of protocol extensions, is probably roughly similar to what the GUI daemon could be made, a Wayland GUI daemon could be made to do using the current or a modified GUI protocol, but I could be wrong on that. Any questions? Marek?
How does permission model works in PipeWire? Like, if application wants to recall value, what needs to happen to allow that?
So by default, an unsandboxed application can just do it, which is there's no need for a sandboxed application like in Flatpak would presumably need to go through XTG desktop portal. I have not tried that, but in Qubes that would likely be handled via our own mechanism. It could also be the other option. The other option also is that instead of having audio recording be governed by a permission mechanism, the other option is to always allow recording, but by default, the stream being recorded is muted, which means it's all zeros. And in fact, the current PipeWire module emulates that because it turns out that's necessary. Any other questions?
I was just going to ask, how backward compatible is PipeWire with like programs that use, I don't know, something else like audio or something?
Very.
Very?
It's and as in it should be complete. If not, my understanding is that's a bug.
Okay. Yeah, there are dropping ladders that with API compatibility.
It's not just API compatibility, it's actually wire protocol compatibility too. Because there's pulse audio, PipeWire implements a server that speaks the pulse audio protocol.
Yeah. I was thinking of dropping, we had this disgusting hack where we use a interview shared memory device for the audio as well, and somebody figured out how to do it using PipeWire, and I was like, oh, okay. Just, does that work with everything else? I guess yes. Cool.
And also, yeah. So yeah, what were you?
Yeah, I was thinking, do you see it feasible for there to be some synergy between you guys?
Yes.
Yes.
And do you also have some sort of vision on that already, or did you discuss that? Or?
I believe this will be one of the topics of the
we've already discussed it some, I think, but there's going to be more.
We can to be honest, do the segue to the design session because it starts like the next thing, and like we can easily continue the topic now because I don't know, Marek, how you want to deal with that one.
Yeah, so we have I think several of those presentations after lunch was like preparation for the design session. Yeah. GPU virtualization with Wayland, with PipeWire, all those topics we can discuss. Cool. Yeah.
Okay, so we are back in 10 minutes.
Thank you.
Okay, so we'll be doing a design session now. So it will be mostly discussion about things we talked. We had presentations before, and for today I'd like to discuss some topics about audiovisual stuff mostly. So we are adding support for Wayland. We have pulse audio to PipeWire migration, and something I'd like to see at some point in Qubes, also GPU, virtual GPU in VM. As for Wayland, then can you summarize what problems we still have not solved with Wayland?
So, on the agent side, the biggest thing missing right now is Wayland support, which is just a matter of actually doing it. Which is just to get, like, the only reason that's not there is because it hasn't been implemented. And tray icons, which don't work because I haven't implemented status notifier item.
Regarding status notifier item, is it something that is that some part of code we could, for example, share with Spectrum project? What do you have any ideas?
I don't see why not. But I'll leave that. I'll listen to what you vote.
I have thought not one bit about status items. Have you thought?
A little bit. The thing is that status notifiers, like tray icons under Wayland, work completely differently to that under X11. Namely, on X11, a tray icon is just a tiny little window that the window manager puts in a little tray. On Wayland, it goes to dbus, it goes to a bunch of stuff, and it ends up being way more restrictive. I suspect that currently for tray icon support under Wayland, it's going to probably end up being a thing that may actually, we could probably use some shared code for things like having to handle dbus in general for a lot of these new fancy features like screen sharing.
Yeah, I was thinking that for the portals as well, actually. We're going to need something that does, we probably don't want to be doing inter-VM dbus, so...
You can't anyways, because file scripts are passing.
Looks at OpenXT, which does inter-VM dbus.
Wayland also has file descriptor passing, and that's fine. But,
more restricted.
But, so we might want something, I was thinking to do dbus, implement, say, the portal dbus endpoints, and then turn that into a custom Wayland protocol or something to then reuse since we can already transport Wayland messages.
I mean, obviously, for Qubes, we've got to use QR exec or a custom GUI protocol message or something. I don't know. But I'm thinking especially the parts about turning the dbus stuff into actually implementing the dbus endpoint and then firing callbacks on that. I guess the question is, do you want to share do you want to use a common protocol, for instance, what protocol, what do you want to use for your version of QR exec?
So that's so far not entirely nailed down, but I am leaning towards just using Wayland for it, since Wayland is a fairly generic IPC API that you'll have to implement anyway.
You mean wait, I'm trying to understand that. How are you going to get okay. That seems iffy, I guess, in that Wayland is designed as a control plane protocol, not as something where you're passing gigabytes of data over it.
Well,
It totally is, like, because it's all about shared memory and stuff.
You mean,
like, you would, if you were to say pass a tray item, you would send it, like, you could send a message saying, oh, this debus message was sent with an image as descriptor, and here is a shared memory copy of that image.
That's interesting. I was just not, because like when I say because like QExec is used for stuff like backups, which are going to hit hundreds of gigabytes.
Right.
So
at that point, you would, yeah.
Yeah, because shared memory doesn't really work for that, and you don't want to use.
Virtual GPU does, and like virtual GPU Wayland stuff does support like one-way pipes also.
What about VSOCs? And VSOC.
VSOCs to me seem just sort of redundant since like VSOC basically gives you something that looks a lot like an internet socket, whereas over Virtual GPU we have something that looks a lot like a Unix socket. And an internet socket is just a more limited version of a Unix socket because you can't do the shared memory and stuff. So supporting both.
At best, we could even have a second, like we could have an extra context time for the GPU that just does like dbus or like a pure exec like protocol.
So I'm just curious, like you might have asked you a question, but the VSOC, we use something with VSOC, but the big problem with that is that it only works really in like Linux guests. And we've tried doing something with Windows that's like kind of roughly equivalent, but it's like, it doesn't seem to really work.
Yeah.
Would VirtIGP think be like a Unix socket like replacement, and then maybe I could use it for Windows also?
I don't know. There are Virtual GPU drivers for Windows, right? At least for virtual.
Like could I repurpose it for some generic data?
Not without modifying.
You would have to modify the drivers obviously, but Windows at this point does have the concept of Unix domain sockets. It just doesn't have the concept of sending file descriptor over that.
Yeah.
So I think it would be possible to add like a device to the Virtual GPU stuff that emulates like the shared memory, like or roughly Unix domain socket, and then have some other mechanism to get the file descriptors out using like a IO control or whatever.
So the cringy method that I thought of using is an MTTY, which is like a mediated TTY device. It looks like a serial controller, and then we would have like a, what do you call those things? Like a serial bus where we can just send things back and forth.
Oh.
Yeah.
Yeah, one of those.
So so basically the VCHAN looks a lot like a rather I guess it looks a bit like a Unix socket minus.
Yeah, kind of.
So QExec doesn't need much. The biggest things that are needed for a QExec transport are to be secure and then be fast. Because because you're going to be transferring data at potentially gigabits per second over it.
Yeah, so that's something where I'm guessing that neither VSOC nor Virtual GPU cross-domain have been particularly optimized for performance, because VSOC was invented to be like the sort of the transport for VMware control messages, as I understand it. And cross-domain Virtual GPU was designed to be used with Wayland, which is also just for short control messages, although it also does like copy and paste.
Copy and paste are, right, those are like, yeah, those go over, I believe, the one-way pipes, not
those go
GPU implements.
Yeah, and it's usually not a huge amount of data either, but I guess it could be for drag and drop.
Pictures, copy-pasting pictures.
Yeah.
So there might be a way where, for example, if you have a storage controller, like a PCI storage controller, if it's, I don't actually know much about PCI storage controllers, but in the context of GPUs, it's like a, what would you say? Like a base address registers, and then you can take some of it and pass those through like physically, and then others you can have like that emulated config space. And I think there's like a reference open source driver. It's a sample for like it's not an MTTY. That's the one that people typically look at as a sample. The other one is Actually, it has the base address register virtualization and the pass-through part.
I don't think that we really want to rely on. I think for this we want something more along the line, more surely para-virtualized.
Yeah, if it's fully para-virtual.
We don't want something that it doesn't need to. There's no point in emulating a PCI device here.
So it is actually possible to do. It is up to the vendor whether or not they completely para-virtualize the base address register, or if it's actually passed through.
No, what I mean is that there's no point in even having bars as a concept.
Okay, sure.
It doesn't help. It doesn't need to.
Yeah.
This is all concepts from the hardware world that really don't have a place here, is what I'm saying.
Okay.
You could, for example, what you could do, for example, is you could theoretically make a very high performance, shared memory, type, basically a circular buffer.
Yes, which is what claims do.
For their GPU, shared memory, and cross-domain stuff, for example.
Yeah, because if you look,
it would be a bit of a hack, I think.
I'm not so sure. Well, my suggestion would be to try to implement the vChan API, which is designed to be easy to implement across all sorts of things.
Yes, but there are a few tricks that make it a bit harder, because I don't remember which one, either telling how much data you can write without blocking, or telling how much data you can read without blocking. Some of those concepts is not so easy in all the.
It's implement vChan is a vChan. So to give you some context, in Zen, for vChan, there's no emulated device at all there. It's everything's done in Zen. Everything is done through hypercalls.
Okay.
It's so if vChan is implemented as a shared memory region and some event channels for signaling.
Okay.
Right. So that's basically what I was suggesting with the Verzero GPU shared memory thing.
Yeah, that would work well. Basically, have the bulk data goes through shared memory, but basically there's more data and stuff goes through the.
By the way, the current implementation of vChan for KVM is using this shared memory. What was the name? IVS with interrupts support. So this is using the same data model as vChan on Zen, but based on different implementation of shared memory. But it doesn't need to be this way. It can be this way, but
yeah.
We could do vChan on Verzero GPU using shared memory buffer and probably two one-way pipes for notifications out of function.
It has some. Do you know how to doorbells and stuff work?
The issue with the doorbells is you want to probably actually have something that interrupts.
Right.
Because otherwise you're going to be idling a lot, waiting for the CPU to be yielded to the other VM that is trying to receive the data.
Interesting.
And you could do this with the two-way mechanism that Verzero GPU has, but you only get one of those currently, because there's nothing other than the primary Wayland protocol does go both ways, but no file script issues sent over and have to go both ways.
Okay, so the word act, you could just use a pair of one-way pipes. I'm not sure what their performance characteristics are.
Lots of IOCTLs.
What?
There's a lot of IOCTLs to read and write. So
it's not very fast.
It's going to be slower than shared memory and interrupt, I'm pretty sure.
Okay, so that is.
But for signaling, it should be fine.
Yeah, for signaling, when you have a large buffer of a few megabytes, you don't want to be able to have to write that in smaller increments.
So yeah, okay, this makes sense for what was I going to say, for Qubes. Good news is if you implement the vChan API, you can just steal all of our QORG code, because that's literally all the QORG stuff depends on.
Is that something that we would have to implement in the VMM then, or you're saying it's hypercall?
No, the vChan API is a C API. It's,
like a library?
Yes, it is a C library that you link against. And the only thing QORG depends on is, Well, okay, I think QRexec depends on an implementation of that, and it needs some way to turn and the management port needs some way to turn a VM ID into a VM ID number into a VM name, I think.
On the DOM0 side, or host side, whatever you call it, you also have this policy engine, which is kind of depends on other Qubes infrastructure, but this is a standalone component you can replace with your own policy engine and use the whole.
What other infrastructure does it depend on?
You need, I assume, the VM number to VM name is because Zen uses like uses an ID number.
Yes, that's.
If you have something like client hypervisor or whatever, that doesn't explicitly use an ID number, so you can just use the name for the vChannel.
Well, the vChannel API does expect an ID number.
Yes. There is 32 bits field in the protocol for the
question.
And some protocol messages use also name, because when the VM makes a call somewhere else, it uses target name, which can be a VM name or can be some special keyword.
So what I was going to say is, would it be possible to extend the vChannel API to include a 64-bit VM ID field? Because that way.
I would go for 128 just say put the UID in there.
Okay, the reason I suggested 64-bit is that that's enough for an increment encounter.
Yeah, but I think UID may be more convenient for some other users.
Yeah, you can have them persist longer and use them internally instead of ID numbers.
One way we can do identification of VMs on the Spectrum host is using the state of the cloud hypervisor process, which is guaranteed unique.
No.
But not reusable.
It is reusable.
Yeah, sorry, that's what I mean. And it can be reused, but it's guaranteed unique.
Yeah, 50 minutes.
Yes, but the fact that it can be reused creates nasty risk conditions. That's why in Qubes we just flat out ban exciting reuse with a hypervisor.
Yeah, so that's actually the QRexec thing. In QRexec side, that's the issues.
Yes, it's like we just flat out ban it with the hypervisor patch. I'm planning on working with the Zen people to have some concept of like virtual XIDs, where you make a hypercall, where you pass a 64-bit ID number, which is just an increment encounter, and a hypercall, and that gives you a temporary 16-bit ID that is specific to your V, that is only valid in your domain, and that is valid until you explicitly release it.
Capabilities.
Yep.
Because basically, yes, because that way that will allow lifting that restriction, hopefully. But anyway, go ahead.
Yeah, going back a bit in the discussion, I think if we have something similar to like vChannel API, I suspect that having some kind of shared dbus, like either dbus or a subset of dbus API explicitly.
You don't want to have dbus up between VMs.
Yeah. Oh no, like having mostly just meant getting dbus out of the VM and then posting it somewhere else.
Oh, I see what you're saying. So basically, VMs. It seems like the VM side can be shared. Everything shared except possibly the actual sending data back and forth, but that can just be a plugin.
Yeah, and by the way, the QRexec API for services is just a standard input-output. So the QRexec service is talking for the standard input-output, and QRexec makes some magic to pass it to another VM, also to standard input-output. So it's, the services themselves, they are pretty much Qubes agnostic.
So yeah, so basically, that should. But anyway, so for the tray icons, it seems that the VM side can basically almost all be shared. But as far as the DOM0 side, the host side, I'm guessing that most of that can be like. My guess is that on the host side, you're basically translating that into a call to whatever the host status notifier item implementation is.
Yes, and
in which case that could also be shared.
Yeah, and we also need some indication of the origin of that particular.
Yes, but that's just a matter of image processing.
Yeah.
So I would imagine that pretty much the whole thing, except for the actual inter-VM communication mechanism, can be shared.
Yeah, that sounds reasonable.
Okay. So, go ahead.
Do we have similar issue with notifications? Because currently each VM is running its own notification server and is popping on X11 windows, and if two VMs send notifications at the same time, they overlap over each other.
Yes.
It's horrible.
You could indeed, like, notifications are also DBus protocols, so you could...
Can we also share a notification implementation that just proxies to whatever the host's notification?
Yeah.
Because I assume that, because my understanding here is that, like in Qubes, we support many desktop environments. My understanding is that in Spectrum you only plan to support maybe one or...
Well, we'll see, but I'm not committing to more than one.
Yes.
But
though
yeah, what you could do is you could just have you can have a state that's running on in the GUI domain, and just take whatever notification, like URXF API, and turn it back into DBus messages.
Yes.
And send it into the notification daemon of...
Yeah. Okay, so that all can be shared.
Yeah, and this, somebody already implemented some proof of concept version of this. It's very limited, like it supports only text notifications, and apparently some applications put an icon and a button and stuff like that.
Yeah, but also the other thing is that it turns out that there have been vulnerabilities in text rendering stacks.
Oh, yeah, that's good.
Which is
notifications, as far as I'm aware, the notification API does is support some amount of like fancy rendering.
It supports full Unicode.
Well,
full Unicode.
More than that, plus a little bit of formatting.
Yeah.
At least in when I was running Awesome, I could make notifications. Oh, and it wasn't actually a notification API. I might be wrong on this, but yeah, full Unicode. You want to be able to isolate that.
So here I had two thoughts on that. Because we're both going to have this problem. I had two thoughts on that. The first, there's a few different approaches. One is to try to sanitize the text and only allow a subset that hopefully the text rendering engine will not.
You need to do this anyways, because otherwise you can't distinguish between notifications from different VMs.
Why?
Well, if you have, you could have make a fake notification saying do this thing, and you click on it and it goes to you could have a fake accept reject and it goes to the login page and it's hosted by a completely wrong app VM.
Wait, I don't quite understand what that has to do with sanitizing Unicode.
No, just generic, you have to process the notification.
Oh yeah, you do. Oh yeah, no, yeah. That you do, but that's easy.
Why weren't you talking the other day about how notifications, what if notifications were just surfaces? And then,
yes.
and then the VM was responsible for rendering them, and they just
this was separate from having the VM be responsible for rendering was separate,
but it would also so it would solve this Unicode problem.
Yes, it would. So I was thinking about a completely different thing, which was getting my Android notifications on my desktop. The issue is notifications on Android are a lot more rich than notifications on Linux.
What do you mean?
Notifications on Android are complete views. They have styling and buttons and images and everything.
Wait,
way more than just a picture.
Who renders them?
It is a very restricted subset of view data that is rendered by the notification tray. But the point is that I was looking into this and I figured out that Google, again, they're doing a lot of this isolation with Wayland stuff already, but not quite to the degree of security. They have a protocol for doing notifications as services. So instead of sending over notifications actually, you would send that over still with accessibility and whatever reasons. But the notification contents themselves would just be a Wayland servers that can also could even be animated.
And then the compositor just would render that service, and it could still put a colored little ring around it or something.
Yeah, but you end up with a lot less responsibility because you don't have to render the text.
So that's an interesting thought. I guess my first thought is that you don't just want a color ring, you also want the VM name.
Yes.
And that would be much harder in that model.
Why? Just because it would use more space?
Yes, from a user experience perspective. Marta, are you here? Yeah, what are your thoughts on that?
That was easy. That's true. I'll answer.
Explain. What exactly do you want to know?
So for notifications, is it better to have the VM name right alongside?
I mean, I can already answer you that it depends. Because it's always that answer. Like, I don't want to answer you, okay, for notifications we want that. Because
well, the reason I'm asking is
there is no, if we could design things so they work perfectly regardless of context, well, that would work if we were robots, not humans. And yeah, I guess that usually it's important to know what VM the notification is associated with, but that may mean VM name that's very visible, or that may mean VM name that is easily discoverable, depending on the context. And on what kind of notification is that.
Well, because it looks like we may have to have a more generic solution because of complexity.
Yeah, another issue with notification daemons under Wayland at least is that they are slightly privileged.
Yes.
Because in the case of WL roots, they use a protocol called layer shell.
Yes, I've heard of layer shell, which is very privileged. You can make a stream locker with it.
It is privileged, but not quite to that degree. You still don't get access to absolute position. You just say, I would like this window, this surface to show up on this location of the screen, like attached to this corner of the screen, basically, or have it be full screen.
Yeah.
And yes, it is privileged, but it's still relatively I would still consider it to be relatively safe. You would want to restrict this to specific VMs.
I don't think you'd want to expose it at all. In Qubes, I don't think we would expose it at all.
That's reasonable. Yeah, I was thinking of reasons other than notification daemons, and I came up with the status bar.
Yeah, I don't.
Yeah, that's going to be handled on the host.
I don't think we'd want layer shell exposed.
Yeah. So my thought is that, my thought was, because my understanding was that, Marek, the reason I was, and Simon, the reason I was somewhat okay with thinking that Wayland could be a decent replacement for the GUI protocol is because the only things we need to expose are Wayland.xml minus the obsolete WL shell, which we don't need, and plus XDG shell.
Yeah.
And yeah, I think that's it.
You would probably want to get XDG foreign in as well.
What's XDG foreign?
So, I mentioned this a bit and then forgot to talk about it more. When you use XDG portals, and you use, for example, OpenSafe dialog or screen sharing prompts, which go to OpenDepos,
yeah,
the pop-up that comes up asking that is privileged, but it is, and it's run as part of a different client.
Yes.
But it is parented. It is a pop-up that is parented to the window that was trying to open or save. And it does so by basically making an exportable handle of a specific window that then the other side can import and use to parent, to create new children for that window.
Interesting.
So it's one of the few exceptions really that actually pass information between two clients. It's still very limited. You can't do more than parent or reparent windows.
I'm not sure we want that because it might defeat protections against what's it called?
Clickjacking.
Clickjacking, yes, and other similar attacks.
You might want to limit it to only exporting handles and then have things like the screen sharing dialog be privileged in a way where they are allowed to use that handle.
I don't even know if you want them to allow it to use that handle.
Well, I think it means that if, for example, a window in the background is trying to do a screen sharing request, it won't suddenly pop up in the middle of the screen. It will pop up it will pop up associated to the window that was requesting the screen sharing.
The question is, do you want that, Marta?
I would say yes.
No, I think it's important to distinguish pop-ups that are privileged.
But another thing is that you want the pop-up to be associated with the thing that is requesting that.
Do
Like,
you?
if you just
Well, how does the user know where what
Like,
Because the pop-up text contains it.
Right.
But it doesn't always contain it. Programs may have their own pop-ups that may not be very obvious outside of the context of this program.
Well,
Yeah.
these pop-ups
We're talking about privileged
provided
Yes.
not by the application.
Yeah, but it's
What-
still better to
Wait.
have it be
Wait,
visually associated, IMO.
So you're thinking here how to show a pop-up, like a notification message securely, that like can't just any program draw anything on the screen already with the override redirect
Well,
thing.
it's more about like
A, override redirect won't work once we switch to Wayland.
Oh.
B, override redirect still has a border.
the thing here is that if you like open a dialogue, like you can tell that it's privileged because it doesn't have a colored border or whatever. But the issue is you can't tell what it is associated with, and the name, like you would have to put the FPM name in the request.
So I'd say like, I'm just thinking here more from the user perspective, not so much like on the underlying security thing. But I think showing something as far, for example, the like a panel with the notifications like they do in the GNOME project, the users may see that as something that is privileged because it's part of the UI, right? The user would click there and they could see, for example, the VM name and whatever text the VM chose to render in that section. Whatever would show outside of that would not be a notification and could just be an application trying to, I don't know.
The other thing is that I believe that if you have a dialogue, like one of these privileged dialogues, if it's part of the, if it's a child of a different window that isn't currently focused, I believe it probably doesn't get focus.
Yes.
So you like avoid keyboards click jacking effectively.
But you can also have, for example, like an application is running in the background that needs to notify the user of something, right? And then the user would miss an important notification, and then they.
This is slightly different pop-ups than those, I think.
Okay.
Yeah, this is mostly like file open pop-ups. where you
Keyword
want to,
exec.
like,
So I think for keyword
grant an
exec,
application access to one
I
file.
don't.
Yeah.
So in most cases, it's tricky.
But in our case, those dialogues would be still inside the same VM, right?
Yes. No, the dialogues would be rendered and handled by a different VM. Like open
Which dialogue? Not open file. We
Not
don't-
open file, but maybe screen sharing.
But for example, screen sharing and in the case of Spectrum, probably the open safe features as well because that is a good UX.
Okay. So, open safe what?
Open safe dialogues. Like if you're running in Flatpak, for example, and you try to open a file.
Yeah, that open safe dialog seemed like a huge attack surface though, for Qubes at least.
Relatively, but you could implement it as an equivalent to like the open dialog, which is like you would select the file, it would be copied into the VM.
So basically, with built-in QVM copy on QVM move.
Yes.
Okay, that makes more sense, especially if you sanitize file names, which we
Yes,
currently
you could do that.
which we currently don't, but are planning on doing.
Yes, but you could. But then, if you then try, for example, if you have like a PDF view, you try to open it, you hit the open button, it would pop up a dialog that's visually privileged, just shows your files.
Yes.
And you can just select the file, and it will like possibly pop up a little copying dialog that shows progress.
Okay, that makes sense. Question: have you seen the Qubes GUI protocol, either of you?
The current GUI protocol.
Yes.
Yes.
How complexity-wise / attack surface-wise, how does it look like it compares to XDG shell plus Wayland.xml minus CDO shell?
I would say that XCG shell is obviously a bunch more complex, but for a bunch of reasons that I believe are reasonable.
And like what? And how much? Like what?
Well, there's more features like draggable surfaces. Like if you get a click event, you can turn out if you get a click event in XDG shell, you can tell the compositor, okay, this window now should start dragging.
What do you think? Should Qubes allow that? Or
I think it would because I saw a few of the pictures in the presentations and like you have these. Well, what are known already kind of depends on client-side decorations.
Yeah, Qubes isn't going to support that.
Yes, I know that because it's a security risk, etc. But you still have a bunch of that client-side decoration that you can click and drag, click to drag the window around, for example.
I see. What do you think, Marek and Simon?
But yeah, so clicking inside window is fine, but dragging outside of window border is something that I'm not that comfortable.
Well, the application would be moving with you.
Oh, so it would be.
It would be like you know like.
How is it different from what we have right now?
Right now, like for instance, Chromium has these decorations that don't actually work.
Like if you look at modern GNOME, like the title bars in there.
Yeah, but if
you can't drag in cubes if you grab one of those like the GNOME title bars as opposed to the Qubes title bar. I think actually it doesn't work with it.
I'm not sure. In theory, it could work because the VM received the mouse down event and then can actually request the window to be moved.
Yes, but in Wayland you don't get to move your window yourself.
Oh,
you're limited only to telling the compositor,
please start
please
dragging
move my window with the slick event, but it won't tell you even where the window is moving.
Is that something that'd be reasonable to allow in Qubes?
I mean, it's mostly just window drag.
It sounds like it's a subset of what you have already.
All these are like relatively small features, but the thing I'm mostly worried about would be mostly worried about is probably the implementation of these APIs.
Yeah, that's what I'm worried about too.
I would consider XCG Shell to be a relatively reasonable attack surface from what I've seen so far.
What do you
Does
think?
reasonable mean reasonably big or reasonably small?
Reasonably small. It is
what do you think?
No comment on that because I haven't seen it.
You should.
Also, when you say
I suggest you two look it up right now. Like pull out your
maybe
phones
this is good thing for hackathon.
Yeah, maybe.
So the question is because this discussion like kind of drifting in various directions in very small group of people maybe, and we are already almost 40 minutes in this.
So the other thing
discussion.
is, what else?
Let me finish. So maybe try to create some hypotheses that can be verified over the hackathon.
Okay.
To move that forward. Yeah.
Yeah, that's a good idea.
Arthur, but yeah, now let's go on to what about like GPU acceleration stuff, because that's going to bring in more people and it's going to be a better use of having everyone here.
Yeah.
So I guess for GPU acceleration, my current thought is that like Intel's SRIOV with a decent kernel implementation as opposed to the current buggy one is good enough, is safe enough for Qubes, while the MDev with the software-based approach probably isn't.
So
what are your thoughts? What are the other people's thoughts?
Yeah, I could just add one thing before we get to that. The mediated devices that's a little bit deceptive is that a mediated device isn't necessarily like software per se. It very much depends on the implementation. So for instance, I'm sure as you've seen, Rich is talking all about scalable I/O virtualization, which is like these so-called IOMMU aware mediated devices. The exact equivalent thing in NVIDIA on Ampere and Newer is SRIOV. It just has a mixture of the mediated device interface, which is basically just an interface layer, and then SRIOV is the back end for accomplishing it. So it just depends on which assistance mode you use.
Yeah, and that's what I'm saying. Like, I think that the SRIOV assistance mode is safe.
Yeah.
I don't know about the scalable I/O virtualization.
Yeah, that's all been developed.
And the pure MDev mode, my intuition is that it probably isn't.
Well, the thing with MDev is that it's a relatively large attack surface in the kernel because you still have your GPU driver and everything. That you're like relatively close, like talking relatively directly to in some cases.
So the thing with
the thing I've really considered for a long while now is trying to get a GPU driver into a VM, but having it export like VFIO mediated devices out of the VM.
So we've talked about this, but somehow having not DOM0 be the thing that actually runs the mediated device driver. However, I think that's all kind of dependent on like what was that Daniel Smith thing with like driver VMs or whatever?
Yeah, and also specifically, this is specific to AMD iGPUs, but AMD iGPUs have this nasty problem where the driver has to interact with the platform security processor, and you can't pass that through.
Yeah. So the first thing is that if we're going to talk about virtualizing AMD GPUs, I hate to be the person to say it, but like AMD GPU virtualization of all of them is like not the best. So I would put that out. Like the one thing that is nice about AMD GPU virtualization is that like you actually, if you look at the way that the host handles it, it doesn't actually even have like the AMD GPU driver code in it. Like literally all the host is doing is just like context swaps, where it's like take this buffer of like the bar space, and then like here's this requester ID that goes to this VM. You're going to be running for this many milliseconds. Okay, unplug, put it into the next one. There's no actual like AMD GPU driver per se in the host, like what you get within like NVIDIA. NVIDIA's stuff is still doing that.
What about NVIDIA? What do you mean not NVIDIA? Intel's ARC.
I believe it is doing their SRIB driver is pretty similar. It's a bus slot function. You don't pass a mediated device, but the mediated device thing is a bit of a like it. I know that it sounds very much like software, and there are implementations that are very much software, but some of them, like literally the parent device per se of a mediated device, is actually just an SRIB bus slot function. So passing that in, because it's using that SRIB bus slot function, is effectively equivalent to just passing directly the bus slot function.
Right. Yeah, media devices are effectively software-defined PCI devices in the kernel.
Yeah.
And there's also PFIO user, which is software-defined PCI devices in user space.
Yeah, but the thing that some people, like the implementation in NVIDIA, in Ampere post-Ampere, is that the mediated device is actually using the SRIB bus slot function.
Hardware.
Yeah, so then at that point you've got the mediated device, and then you actually have the enforcement layer of the SRIB as well.
Yeah.
So go ahead.
Yeah, in this case, you like with NVIDIA, you can do like I think NVIDIA is currently the only manufacturer that has like modern GPUs that can do virtualization of any sort.
About Intel.
Oh, yeah,
Intel does too.
Oh, right, the new Intel chips do it, but they stopped doing it for a few generations.
So it was one gen. It was 10th gen that stopped when they switched over to 11th gen, and then they decided for some reason in the new driver they're like, oh, the development vehicles are all 11th gen. We're not going to support that in like deployment. So
I think that's because of hardware bugs.
Yeah, it's silicon rattles.
Right. Yeah.
But like, if you think about it, if you buy an Intel computer, like a laptop, it has the iGPU in it. So it has the Xe GPU. That means every new computer, like that you get, will have the SRIB GPU capability in the upstream kernel. So no additional packages, and it just comes to every computer.
Yeah.
That's the key. Right? At that point, you use that because then that's probably the best implementation from an enforcement perspective of separation, and it's open source and it's in the kernel.
But it's not
since 11th generation.
That's since 12th gen. It's technically in the 11th gen as well, but the driver, they say they don't support it in the 11th gen.
There's too many hardware routers that make it broke.
Yeah.
It's
unless they
like,
go back on the SRIB and change to something else.
What's that?
Unless they go back on the SRIB and change to something else.
So it's funny that you say that because they are developing scalable virtualization on the same platform. They actually extended the BTD spec to do like more granular IO and MU allocations. Like they have like shared, it's like auxiliary bus stuff where it's like in PASID, which is like shared buffers or shared work queues and things. Like that's their future implementation. But
So 12th gen would make most sense for being a hardware that we work on to enable that.
Yeah,
or dedicated into Xe chips, right?
Correct.
Will they also have SRIB?
They do.
Okay, good, because I was afraid they wouldn't.
They do. So they have.
We have one platform with Obenour working on it.
Being for cloud hardware.
Yeah, so you're talking about what was that thing with
so it's not just the
cloud
iGPUs.
gaming thing? Yeah.
So it's not just the iGPUs, but the Intel DGPUs also have SRIB?
Some of them do. But I will say this, like the thing that's really fascinating.
Does that include the ones that individuals can buy?
So I have certain things that I can say, but what I will point out is that if you read that thread where you do the W7100 thing, do you remember where it's like, hey, look, we can swap this. Remember the problem with that was one of the issues was the host video output stops working because the physical function doesn't output video, but the virtual functions do. I will point out something very interesting about this is just me pointing out that that's public information already, is the fact that if you have a Arc Sound GPU, which has the same SKUs as the Intel Arc GPUs, the same silicon SKUs, the physical function with the SRIB firmware blob does output video, even if you have SRIB virtual functions. Right. So we need to get those.
Are these the
firmware
consumer
clips.
SKUs?
No, the SKUs are the same. Yes.
It's all about unleashing the power which is already there. Yeah?
Similar as NVIDIA GPUs, where their enterprise GPUs use the same silicon but with other different features enabled.
Yeah.
Okay.
It's quite standard.
So we already have here MSI Z690. This is 12 gen. There is Qubes OS there. So maybe there is a way of exercising something during the hackathon.
I agree.
And the question is, like, how hard it would be? Who can drive that? Who can think about, like, I don't know, Arthur, if you can think about that, like, is it like feasible in one day, or this is like completely, or maybe we can do something way smaller to just check.
Part of the thing that I've been like pushing for is the documentation to be made open. It was supposed to be made open like 9 days ago. And I've emailed and I've asked, would you make the documentation open? And I received back a PDF file that was like a standard thing that was just given out. It doesn't seem that all that is documented properly, but if you go and you look in the Intel LTS repository on GitHub, there you can find the patch that's like SRIOE feature enablement. So if you compile that and you run it, like in theory, IM15 should have the thing there, whether or not we can figure out how the utility works to make it create the virtual functions.
Right.
So this is just about the custom kernel compilation?
It is
and
a custom
just
kernel.
Yes, and also the code is apparently crap.
Doesn't matter for the POC and hackathon.
Proof of concept. Because it's a virtual function, you can do faster with Zen as well, right?
Yes, and the best part about it is it doesn't rely on the mediated device, it's a bus slot function, so it works perfectly with everything.
So can we agree on like a first task for hackathon? Like let's take this Intel LTS, compile that in Qubes. I don't know, like maybe Frédéric Builder V2 can help us to do that very fast. And then we will gain a lot of synergy.
Yeah. So that all seems to be a good idea. I guess. How much with the MDev model? How much code is there running on the host that is actually influenced by guest requests?
Right. So my favorite comment from Andrew Cooper was, what was that thing he said? He's like, graphics virtualization in Zen between the different hypervisors. The only thing in common between them is the word graphics. So like, I have.
Can you give me a number of lines of code, roughly?
I have no idea.
I would probably guess too much relatively.
Are we talking about tens of thousands or hundreds of thousands?
Okay, so like
we're single-digit thousands.
I can say like in KVM, it's like here's this block of memory. It's an IOMU group that goes to this guest. In Zen, it's like here's an identity mapped piece of memory in DOM0 that then is talking to like literally is passed to a guest. So I don't know about you, but I think that's a disgusting hack.
Yes, I agree. But that's not the point. My point is,
how
with the MDev mode, like with the MDev mode, there's code on the host that is emulating, that is responding to guest requests. And my question is, how much of that code is there?
It depends entirely on the microarchitecture. Because
how much is there for
like a modern NVIDIA chip?
Yes.
Well, almost. It uses SRIOV technically as the backend. So at that point, I have no idea.
Running on the host.
I don't know.
There's still a lot of like.
Isn't that just a distinction whether the same amount of code is running on the host or in the firmware of the GPU? Like, isn't it?
So it's funny because
maybe
certain things that I can't enable for reasons that you know about don't take the normal pathway of executing in the guest. They execute in some like weird out of band sense where they do like a remote procedure call into the host and then execute there. But everything else runs directly on the GPU from within the guest. I think the reason it was implemented that way is largely because they want certain things to work and they want other things not to work. But that's ultimately, I have to, you know.
So GPU virtualization is always still the option of the power virtualization stuff for VMs.
I'm going to guess that YouTube will nix that instantly. I'm pointing at Marek and Simon.
I don't know. It's as secure as running GPUs like two GPU clients on the same machine, like without any stuff. I would say it's still a large attack surface, but.
Okay, so in the context of if you're dealing with ambient, sorry,
I was going to say, I'm guessing that you two would nix that instantly, and my question is, am I correct?
Doing OpenGL command serialization.
Or Vulkan.
Or Vulkan. Like, and just running Vulkan or OpenGL in the host effectively. Or in a VM in the host.
No. Okay, so
wait, one other thought. Given that SRIOV capable GPUs only have a certain number of virtual functions,
You would need to choose which VM.
well, no. Let me finish. So what I'm thinking is that given that these approach, what's so shocking?
I think I see where this is going.
So what I was thinking is you could have one VM that has a virtual function, and then it uses Virgil or Venus to expose that to more VMs.
Okay, so did you see in my what is it called? In the ETC GVM MDEV GPU in the generate vGPU types?
In the what?
Yes. Config file. The actual number of virtual functions is just the only reason there's only so many is because the vendor hard coded it and then signed the configuration, and then if you tried to change it, then the vendor would go, this is not a valid signature because you altered that file. It doesn't work. That signature doesn't exist with us. We're just like, you want 32? Fine.
Wait, you can expose 32 vGPU as virtual functions on Intel?
Sure, go to 256 if you want. But the problem is if you get to that late, how much GPU is there left? Right? It's not going to be a good idea.
Well, but can you change it at runtime?
Yeah, how does that switch works there? Do you need to statically allocate GPU memory to each context, or can you swap them?
In NVIDIA, they have these resource manager objects, and you allocate the objects by freeing them, which is like a request that's like an API thing internally to them. Intel, I have no idea how that works.
Because, in other words, what we'd like, I think, is to just be able to handle it like CPUs, where you add more or less.
Yeah, basically how much you can overbook.
Okay. Oh, you mean over allocation kind of thing? Yeah, I think you can technically do that up to the point where the GPU doesn't have any available memory left, and then you start getting IOMMU group binding errors when you try to launch a virtual machine. There have been some attempts for.
What about iGPUs that share?
Go ahead to that in a second. There is something where people have looked at trying to do page in, page out. So the idea would be somehow you have the MMIO windows in the RAM, and then those are pinned or whatever, and then you would somehow do swapping to disk in order to get more out of it. That does seem like it would be possible. I know the Windows WDDM driver already does that. The Linux driver does not. So if that could be done, then you could over provision it probably.
Yeah, because without that, we would need to choose GPU, allow access to virtual GPU only to selected VM anyway. Because if you are running, I don't know, 16 or 20 or 30 VMs, if you need to allocate GPU memory statically to each of them, then you won't have much memory each VM.
So the funny thing about it is that if you look at the way that VFIO is written, it requires that whenever you do a VFIO virtual function, you have to basically have these pinned pages in RAM for the MMIO. NVIDIA's implementation doesn't do that at all. They don't use the VFIO PCI kernel module. They use NVIDIA PCI or NVIDIA VFIO, which is basically it appears to do swap. So depending on the size of the workload or the guest actual use, it changes, and it's not just a pinned page in the host.
Okay.
Yeah, so we have 7 minutes left for design session, and I don't know, Marek, what's the goal? But I would imagine that discussion should lead to some measurable goals that we can achieve, or at least to some decisions.
Yeah, so we have one task for the hackathon about this GPU virtualization, and the other thing we can also try is to look at those notification status notifier item and things like that.
I think we should.
What I should
do that in Rust?
Try icons and notifications.
Like,
Can I add one more?
Try what?
Can I
Icons. Yeah. And as far as my first thought is the simplest approach is to go with the sanitizing Unicode route.
Yes. And with the AppVM name in
Yes, it doesn't need to be, I don't think it needs to be ASCII only, but there's like a list of, I think we can go by Unicode properties.
Yeah, you've already written some of that.
Yeah,
I'm not sure how flexible that will be for.
We probably want to reuse the logic that is used with pointer bars currently.
And not ASCII only?
Yes, by default, exactly. And that's why I'm saying it needs to be changed, because I wrote some logic. My current thought is that like simple stuff for it, because this is a context in which, what's we call it?
Localization.
No, yeah, no, well, not just that, but like confusables don't really help the attacker. Like it doesn't really help. It doesn't help if the attack, like the attacker does not gain from pretending that an A is an alpha or something, or vice versa.
Yes.
So it is okay to allow confusable characters.
Yeah, the only thing you would want to protect against is anything that could cause the like whatever indicator for the VM name to disappear.
Yes, and we're going to handle. My thought is to handle that by banning bidirectional explicit markers.
Well, there's a way to protect against those by having your own explicit bidirectional markers first.
Oh, nice.
You also want to protect against things like oftentimes emojis and stuff in title bars push. I think it was some where an emoji would render way too big and it would push most of the text off of the title bar.
You'd also, but what about like rendering exploits caused by weird combinations of like combining characters?
Yes, exactly. I'm thinking of banning combining characters.
Apple and a bunch of them.
A way you could solve this very easily is to just render a static picture for verification and draw that on the screen.
We don't want to do that because of accessibility and other reasons.
Right.
And it also makes for much more complex implementation,
which
means it's bad for proof of concept. Also, the other thing I was thinking of is, what if we, the other option is, what if we use one of the safe Rust rendering stacks? Simon?
If you start adding field text like a notification, you also need to have in mind that whatever you use for rendering might also interpret the HTML or something. So you.
That's easy enough to do by HTML escaping.
My point is when you support multiple desktop environments or something, you
need to know whether or not to use HTML escaping.
Yeah.
Well, it sounds like we might be rendering the notifications ourselves.
Depends. I think initially we shouldn't because it leads to a simpler implementation and for proof of concept.
Yeah.
Can we like define like success fail criteria for this trying icons and notification? So I would try to put something big in notification and looking if things not crashing or what.
I think getting tray icons and notifications rendered out of
render at all.
Like
render at all.
Having them work by not being rendered in the AppVM. Basically, by having something that is responsible for.
To be rendered in AppVM, like
being part of the GUI daemon.
Forward to DOM0.
Yeah.
I'd say the initial success criteria is just implementing the dbus interfaces without any rendering.
Of course, but something that can be achieved in reasonable.
That's what I'm saying. The first step is to just implement the dbus interfaces.
For notification, we already have proof of concept for that, and we can extend that.
Oh,
nice.
So there's already proof of concept on dbus.
Yes, the notification API does indeed support notification. Davis API does indeed support a subset of HTML.
So we need to well, that just means we need HTML and the escape.
No.
I would probably
Why not HTML and the escape?
No,
it's a subset.
It's a specific subset of HTML, but the issue is that you need to pass it through or strip it out entirely.
Why can't you inch the escape?
Because then, like, if you have a bold tag in the notification, it will show up as brackets in the text.
Okay, and for those who do not follow up, like, what does it prove? Like, what? Let's say we'll try this and we will be able to render. What does it prove?
It it would give us a basis for any other DBus protocol that needs any other DBus interface that has to be sent done outside of the VM. For example, screen sharing with PipeWire.
For the proof of concept, I think we can just say I think we can just do this HTML entity escaping for a proof of concept.
Yes, we could just do.
And also the other thing is, now that I think about it, like for instance, I think allowing well-formed tags not nested should not be much of an attack surface.
Probably.
Because that just allows you to set mark areas as boulder attack.
We probably want to strip out hyperlinks.
Replacing them with what's inside.
Yes. And have the icons and buttons. Buttons also need to have messages sent back, which is
That's why the proof of concept doesn't support buttons.
Yeah, I think for proof of concept.
I think having buttons is kind of important as a proof of concept because it means that the DBus messages can go both ways.
Yes, agreed.
And you kind of need that anyways for most other protocols.
Yes, it's like for instance, you can't status notifier item just doesn't work without it. For status notifier item, I think a good proof of concept would be just implementing the DBus interface.
I wonder if the status notifier item API works under X.
It does, I think.
Isn't KDE using it like also on X level?
I think so. Yes, that's what I mean. It's like the API itself is. I think you can. All you need is an implementation of it. I don't have XCC provided.
I just checked that the status notifier API works the other way around from what I thought. As in, each application implements the status notifier item interface. You have to call it to get things like category, ID, title, status, image.
Oh, that sounds annoying.
Yeah, but it's like, it kind of ends up, we have to implement most of this anyways, and you don't want this to be from the status notifier item into the host, basically. But you want to be able to pull this anyway because you could have a lot of small ones and there's image data that is being transferred as well.
Yeah. What are your question? Does our assessment about attack surface for vGPU seem accurate?
I don't know. I mean,
What?
Maybe.
It's a large attack surface either way that I'm like slightly unsure about, but I would say that anything that has like explicit hardware MMU stuff, you could reasonably prove that that works.
Okay.
You could probably try fuzzing it even.
Okay, so there's another thing, like vGPU implementations are obviously extremely different. There's another one that I haven't gone to the trouble of documenting as much yet, but I think is probably more like future oriented. So like obviously like you have a Xeon and you can go like, okay, here's 2 threads, like these 2 physical cores are pinned to this particular virtual machine. But like in the context of actual like vGPUs, it's typically preemptive scheduling, right? Like take literally every one of the stream processors / CUDA cores, plug it into the VM for this duration of time, unplug, go to the next VM, like just scheduling.
Yeah.
It turns out that there's actually another way of doing it, which is only available on Ampere, which is called the multi-instance GPU. That particular implementation is basically a hard partition of the cores.
That's what Qubes would want.
Yeah, and you pin the core, but the problem is it only works on A100, which is like literally like a $1 jillion GPU, and it's like, but the SKUs are the same as a bunch of the other ones, so you can probably poke around and figure out how to get it working.
I mean, that'd be great because that kind of how does Intel work?
They have nothing like that, which is I think why NVIDIA is pushing the big thing so much, because it's all preemptive scheduling. But the thing with the preemptive scheduling in NVIDIA, or with Intel, is that the SRIOV virtual functions have that additional MMU layer protection, which is that the actual requester, so bus slot function, gets bound to like an SRIOV context in the hardware. So like the IO virtual address translation through its MMU controller is actually at the best bus slot function rather than like the mediated device logic just telling it how to do that. In NVIDIA, it's the same thing. You have the bus slot function for the MMU translation, which is layer 1. Like internally, they call it layer 1, layer 2. So layer 1 is the SRIOV, and layer 2 would be the mediated device. So there's just 2 MMU contexts rather than 1, which is
Does Intel have 2 MMU contexts?
Well, no. NVIDIA does, but it depends on which architecture you're talking about. like in the architecture, the newest one, which is Ampere, it has two MMU contexts, so it layers the two translations on top of one another. In pre-Ampere, it's just the one. Intel has one still.
Okay, I believe we are out of time for design session.
One more question. Is there anything we could do on the hackathon that would help the Qubes video companion development?
Yes.
Because I'm kind of interested in that. I mean, I don't know if I'll be at the hackathon, but to be
yes, definitely. So currently, as a broad idea, I'd like for each new component I add to Qubes to have automated tests. And I made automated tests for, I think, screen sharing part, but haven't managed to do that for camera forwarding. And this requires some GStreamer magic I haven't figured out, and this would be perfect work for hackathon, because it's basically reading GStreamer manual and figuring out options.
Also, another thing that would be really good. Also, another thing that would be really good would be a resolution selection menu.
Yes. Yes, but resolution selection is not blocking, and tests are blocking.
Good attitude.
Why?
Sorry.
Why does the test have to be blocking for something that can be tested by just it works, seems to work?
If the tests are not blocking, there aren't any tests. There won't be any tests.
But why does there have to be tests for it? Yes, I know this is bad software design practice.
It's about making sure things work.
Yeah.
Without tests, if tests are not required, there won't be tests for things.
Yeah, and
this
also,
is always how it is.
Automated tests make introducing other changes in the system much easier, because I'm much less. It lowers the risk of breaking other stuff. When
So how hard is to set up automating testing environment?
Sorry.
So you know, like someone have to write this test and run it, yeah?
Yeah.
So how hard it is to set up the Qubes automated testing environment?
Like for the hackathon tomorrow?
Yeah. Not tomorrow.
Not tomorrow, but on Sunday. Yeah. Just clone the repository. It's already there. There's Python script to run.
Okay, that's good.
Yeah.
So this is easy.
Yes.
Just with GStreamer reading.
For the resolution selection stuff, sorry, I might even provide a patch. Friend of mine has written. By the way.
Oh, nice.
Concept patch. Not quite sure if we can get hold of that until Sunday. Sorry.
Nice.
So there's a patch, and so the idea is to try it, or
not quite sure if I can even like get hold of it until Sunday. So,
okay, so I will not include that.
Is there anything less technical that can be performed, possibly?
And also we will...
what about translations of
Yes.
the sort for various messages in various parts of the code?
Translation-
LogVM.
Hmm?
LogVM.
LogVM, yes, also, but for the translations, I hope will work on some migration to read the docs, like to
not translations for the documentation, but like documentations for the translations for strings in the code.
Yes, but that's some of it already exists. It needs, but we currently have the Transifex project disabled because we lack the automated like pushing and pulling stuff for the documentation, which made a lot of confusion. Yeah.
I just realized there's a potential problem.
Yeah.
Oh no, it's just
oh, okay.
The CRUD is that for at least get text, the translated string is often a C format string, which means that you have to trust. Which means that we either have to write the get text API with something that checks for format string mismatches and ports, or we have to trust the form. We have to trust that basically. I don't think it's designed I think we'd have to review all the various translation files.
But most of that can be automated. Like if you do that in Python, for example, Python already catches mismatching in the formatting, like format strings. That's okay.
So there's not time to propose sessions for the hackathon?
Like the point, I told Marek that the idea of design
Yeah,
session
so
is exactly that the output is some kind of measurable tasks for hackathon. So I believe we define something, and we trying to define something in area of GPU subsystem. I believe.
Yeah. So generally, we'd like to collect tasks before Sunday, and one of the output of one of the source for the hackathon tasks is for those design sessions.
Yes, and the other design session will be tomorrow for low level, like firmware related stuff also.
Okay, because I have also a proposal that I can say later, which is like non-technical.
Okay.
Yeah, perfect.
Sorry for like taking up so much of y'all's time.
No problem.
Did I?
We get used to that.
Well, did I? I mean, like, seriously.
Demi, I got you on VPUB how many times? 3 times? 2 times? 3 times. So I know that if I will allow you and Andrew Cooper to talk, that's end of the VPUB. Okay, anyway.
It's also my favorite place to learn.
Yeah, they have always great topics and like hardcore advanced stuff that your mind is blowing, yeah? But we survived to the end, and there is award for that, yeah? So Mitch is waiting there, and there are t-shirts. So please take one t-shirt. No? Why?
Sorry. Between me and my...
and we see each other at
You can stand.
I'm sorry. Okay. So there is reward for those who survive so far. Mitch is there with the t-shirts, and we meeting each other in Suhr at 7:30 p.m. I believe some of us maybe will go right now because I don't know if I will go back to hotel but we have reservation since 7:30 p.m. So
regarding t-shirts, you have to decide on your favorite color. It means that we have black, blue, green, orange, and violet. Most of them are black. It was Marek's decision. And we have
and they were in green.
S, M, L, and XL. So if you will queue in the front of the small table, I will handle you your selected size and color. At least they are still available.